morning, everyone. It was just from some technical fault. So I think I'm audible to all of you. So topic of discussion is the generation of biofuel. Okay, you just give a response, guys, like I'm audible to everyone right now. So just respond me that I'm audible to all of you. Okay, fine. So I was talking to you about the generation of biofuel. Last day I discussed with you about the primary biofuel and secondary biofuel. What will come in generation of biofuel? Listen, guys. First generation biofuel. First generation biofuel. First generation biofuel. Okay. What will come in the first generation biofuel? Okay. What will come in the first generation biofuel? Listen, actually first generation biofuel was those where we people first time, even here we people started a first time the use of biomasses for oil production. Okay, but overall, guys, I can tell you what about the sources of biomass in the beginning. Directly we have started biodiesel? No. First time those sources people have started to use, that was here first generation. Even directly what were the sources we have used here, guys? Okay, what was the sources here? You just see here, guys, like direct use of biomasses, direct use of biomasses. Okay, direct use of biomasses, even biogas type of examples. First of all, these type of biomasses sources consider okay as a source of energy. So these all were the first generations. Even a part of it, guys, sugarcane and maize derived. Sugarcane and maize derived. Sugarcane and maize derived ethanol production. Ethanol production. Unlike other plants also, many of the plants, that all were considered as a first generations. These all were considered as a first generations. Okay. But you people must be clear that sugarcane and the maize type of examples, and other etc. Okay, they are the edible crop. They are edible crop. Fine. Now come next. Second generation biofuel. Now come second generation biofuel. Second generation biofuel. What kind of changes people have done? Because in the first generation biofuel, here you can see, guys, these are edible crop like sugarcane, like maize. So somehow we are going to create a problem. Problem for what? Food. Problem for what? Competition with the food crops. This type of problem we are going to create in the case of sugarcane and the maize. These are the edible products. Here we are going to utilize it for ethanol or other biofuel productions. Okay. Second side. What about the second generation? Second generation biofuel, here you will get, okay, here in the case of second generation biofuel you will get Jatropha and Pongamia. So right, Jatropha and Pongamia derived biodiesel production. Jatropha and Pongamia derived biodiesel production. So Jatropha and Pongamia derive biodiesel production. Okay, Jatropha and Pongamia derive biodiesel production. So here you people are using non-edible crop. Okay, here what is it? This is non-edible crop in the case of second generation biofuel. See, a part of this, guys, those you are telling me like Jatropha and Pongamia based biodiesel production, a part of other, like even generally biomasses. If you have some idea about the cell biology, you know plant cell wall is made up by cellulose. Plant cell wall, main composition of the plant cell wall is a cellulose. Cellulose is a kind of carbohydrate. If you take a cellulosic material, if you people will take a cellulosic material, okay, Through the help of some microbial activity, that cellulosic material can also convert into biodiesel production, into biodiesel. Very simple. Okay. Okay. What is here? Listen. In the case of second generation biofuel, I'm telling you cellulosic material. I'm telling you cellulosic material. So I'm telling you cellulosic material. Cellulosic material. Cellulosic material means I'm telling you plant derived. Plant derived. Even last year in 2020, UPSC has one question about comparison between plant cell and animal cell. Here in this comparison between plant cell and animal cell, one statement was written there, cell wall, presence of cell wall, presence and absence of cell wall. It was right. So I'm just telling you guys the plant outer layer, whenever you see the cell and all, they're made up by cell wall, and cell wall composition is cellulose. So I'm just telling you, even generally I can tell you guys, most of the biomasses are the cellulose, have a cellulose. So what we people will do here in this case? Okay, whatever we people do here in this case. Okay, see, this cellulosic material, through the help of certain microbial activity, here I am telling you certain microbial activity, through the help of certain microbial activity, through the help of certain microbial activity, this cellulosic material will convert into, this cellulosic material convert into biodiesel. Biodiesel. Even one of the fungi name, fungi, you know, fungi is a kind of microorganisms, even identified, and the name is Gliocladium roseum. Gliocladium roseum. This is one of the fungi. Gliocladium roseum. This is one of the fungi, even identified, guys. What is the role of this fungi? This fungi do the conversion of cellulosic material into biodiesel. This fungi do the conversion of cellulosic material into biodiesel. Okay, so it's a fungi in as a microorganisms. Some more example I can tell you guys. You just listen. When a maize plants, you are going to convert into ethanol. So definitely the maize have lot of byproducts. Definitely this maize will have a lot of byproducts. Okay, this maize will have a lot of byproducts. Okay, so this maize based byproducts is also richer source of cellulose. So I'm just telling you maize byproduct. You just see guys, maize byproduct. Again I'm telling you maize based seeds and all we people can use for the production of ethanol. But second side, maize based byproducts. Okay, maize based byproduct. Okay, and one more I'll tell you guys about neem seeds. You know, neem plant have a plenty of seeds, and the seeds have no uses. But still, guys, chemical scientists, okay, what they did? These type of products have also the bulk of cellulose. Okay, that can also be converted into biodiesel. So ultimately, the sources of biodiesels are a lot, guys, a lot. A lot of biodiesel sources are available. A lot of biodiesel sources are available. Okay, everyone, this is here, guys. So these are the second generation biofuel. Okay, again I'll tell you guys, what is the purpose behind these generations? Knowledge, understanding. Slowly, gradually people understood, oh, this is also a source that we can use as a source of energy. Later on people identify a part of some other sources are also available. So time to time, you know, new evolution happen, and that being as popular in the case of biofuel as generation. So in first generation, what kind of things are coming? I hope you can see. Second generation, what you people can see? I hope you understood. Now we'll come into the third generations. Third generation was also UPSC question in 2018 and 19 prelims question paper. So now come third generation. It's a Gliocladium. It's a GLI. Gliocladium. But see guys, UPSC never asked the name of any fungi and bacteria. Okay, UPSC will never ask you it's a Gliocladium roseum or something. But as simple information you remember, this cellulosic material can also be used for the biodiesel production. In this way you remember, by the help of some microbial activity. Okay, by the help of some microbial activity. Okay, so I will increase the font size, don't worry guys. So first generation and second generation you people understood. Why the fun side is you people are not feeling better? It means you people are using your mobile phones. If you have a laptop, your tab, so easily you can see the big size, everything fine, properly. Okay, but I need to have a many comparisons. That's why sometime it happened that few generations are together. So easily I can do, comparison very easily. As like here you can see the edible crop we are using generally here. And here those plants and their own byproducts we are using, it's a non-edible. It generally have a comparison, those you can see here in this case. Here you people get it as ethanol, but ethanol mixing we people are doing in the petrol. And this biodiesel mixing actually we people are doing with the diesel. I hope you understood. Okay everyone, so this is the everything. Okay, this is everything in this case. So first generation, second generation. Now come into the third generation. Now come into third generation. So third generation biofuel. Come, third generation biofuel. Third generation biofuel is important. Third generation biofuel got popular. I have done Arvind, okay. Third generation biofuel is called as a algal oil. Is called as a algal oil. Third generation biofuel is called as a algal oil. What is algal oil? Algae plus oil. What is it? This is a algae plus oil. Algal oil. Algal oil means algae plus oil. So algal oil means algae plus oil. You better remember. So algal oil means algae plus oil. What about the algae? Algae is a very specific group of plant. Algae is a very specific group of plants. And one of the property of algae, I'll tell you, algae are aquatic in nature. These are aquatic in nature. Algae, this is aquatic in nature. So algae is what? This is aquatic in nature. Algae are growing in the water bodies. Okay, and one thing more guys, every type of water, alga grow. Every type of water means either it's a fresh water, like ponds, lakes, river. And the second is marine water. And second is a marine water. Marine water means I can tell you sea oceans. So everywhere ubiquitous. Algas are available in all type of water bodies. It's a fresh water and marine water, not matter. Everywhere in the aquatic system, alga present. Okay, alga present. Okay, fresh water you know very well. It is on continent. And marine water you know sea oceans. Fine. Actually, some of the algae are identified. Few name I will tell you. Botryococcus brownie. Again I repeat, the name will not come. But inside the notes I will tell you. Botryococcus brownie. This is the name of one alga. The second is called as a Cyaochytrium. Cyaochytrium. Even Dunanella. Some species of chlorella. These all are the name of algae. What even identified guys? In these alga, overall, Botryococcus brownie, Cyaochytrium, in these alga, 70% in their own dry weight. Why I am telling you dry weight? Because alga is in the aquatic system. So of course water is there. When the water remove later on overall the weight into the alga, here 70% in their own dry weight have again what? Lipid constituents. And lipid I told you guys in the last day, from Jatropha and Pongamia, what we are getting? We are getting lipid. We are getting lipid. And if lipid you got it, the rest you people know very well. What you people do? Trans-esterification process. And the lipid will convert into biodiesel. And lipid will convert into biodiesel. Trans-esterification, a lipid will convert into biodiesel. Okay, biodiesel. So it's a procedure. I hope you understood. So what is going to be happen here? I have everybody clear. Lipid is going to convert into biodiesel. So very simple, guys. Again, you got it, the lipid, those you got in the case of Jatropha and Pongamia. And one more statement, those you people know very well. Transesterification process is a very difficult process. Transesterification process is a very difficult process, you people know. So it's entire thing. It is the entire thing. But one thing I'll tell you, but that is very, very important. Third generation is very advanced. And third generation have a good future. And third generation, it can come in your mains paper also. Third generation was a prelims question paper in 2018. Okay, it was a question paper in 2018. And overall the generation of biofuel, what is the biofuel, how it is useful for to fulfill the demand of India, energy need and all. In that way question can also come in your paper. Okay, so here third generation, you write how third generation is better than earlier generation, right? How third generation is better than earlier generation. Right, how third generation is better than earlier generation. How third generation is better than earlier generation. Is better than earlier generation. How third generation is better than earlier generation, right? Okay. How third generation is better than earlier generation. See one thing, guys. Those plants you have seen in the first and second generation, either you can see like sugarcane and the maize. In the second generation, you can see like a Jatropha pongamia. All these plants were grown on land. Okay, land. And here the plants you are growing into the water bodies. So ultimately you are not going to create any competition with the food crops. Because here the growth is not on the land. Land you will left only for cereal and grains and some other purposes, those you will take as a food. But alga, no competition with food crops. Because alga is in the water bodies. And lot of the waters are left into the India, okay, which has not any uses. So you utilize this, the growth of alga, and then you take production of diesel. So the one point, no competition with food crops. So first is what? No competition with food crops. So the no competition with food crop. This is the first benefit. No competition with food crops. Okay, no competition with food crops. This is the first benefit. Okay, no competition with food crops. No competition with food crop. The first point. Second, guys. Algae are fastest growing plant in the nature. 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 So algae are fastest growing plant in the nature. I'll give you one example. Those Jatropha and Pongamia, you people are growing. Generally, I'll take a Jatropha because Jatropha is very common. Because Jatropha is very common. Okay, because Jatropha is very common. Jatropha will be an adult plant in 2 to 3 years. If you want to grow Jatropha for diesel production, so in the beginning you must have to wait for 2 to 3 years. Because Jatropha will be an adult plant in 2 to 3 years. So then the seeds and all parts will come. And then after every year Jatropha will give a seed. But in the beginning it will take 2 to 3 years. Then every year seed come, every year seed come, every year seed come. Those you can use for diesel production, lipids, and then through transesterification process, it will convert into diesel. But what is the benefit with alga? Alga in the water bodies can grow in 2 to 3 days. Yes, alga in the water bodies can grow in 2 to 3 days. So here you got it as a benefit. Alga can grow in the water bodies in only 2 to 3 days. Okay, in 2 to 3 days. So here I'm telling you, it is the fastest growing plant in the nature. Right in this support, Jatropha will be an adult plant, right? Jatropha will be an adult plant. Jatropha will be an adult plant. Jatropha will be an adult plant in 2 to 3 years. Jatropha will be an adult plant in 2 to 3 years. But alga grow in 2 to 3 days. But alga grow in 2 to 3 days. But alga grow in 2 to 3 days. So alga grow in 2 to 3 days. So here you also got definitely, sir, it's good because here alga grow in 2 to 3 days. Okay, fine. So but alga grow in 2 to 3 days. Okay, so it means, guys, on the regular basis, you can separate alga from water bodies and develop biodiesel. Okay, if every 2-3 days alga grow, even if some fertilizer you will apply into the water bodies, so what will come? If some fertilizer you will apply into the water bodies, so every day, regular basis, alga will, as the fastest growing plant in the nature, they will fastly grow. You again separate the alga, dry weight, you separate the lipids, and then through transesterification you convert into the biodiesel. Okay, you can convert into the biodiesel. Fine. So one more thing, guys, I'll tell you. If you people go into in the respect of comparison of productivity, if you people will go in the respect of productivity, so what will come there? In 1 hectare area, okay, in 1 hectare area, if you people are growing the jatropha, in 1 hectare area, if you people are growing a jatropha, and second side 1 hectare area you make a pond and grow alga. So throughout the year, if you people do the comparison, the alga provide 10 to 100 times more biodiesel in comparison to jatropha. So right, in 1 hectare area, 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 alga produces, in 1 hectare area, alga produces, in 1 hectare area, alga produces 10 to 100 times more biodiesel than jatropha. 10 to 100 times more biodiesel than jatropha. So 10 to 100 times more biodiesel than jatropha. It is a benefit, guys. It is a benefit. It is a benefit in the case of alga. One more point which is very, very important. Okay. Another, what is the benefit here? You just see. Okay, you just see. Okay. Okay, fastest growing plant in the world. Okay, another point. So in 1 hectare area you have seen the production, guys. Okay, now come next. You know, wastage of jatropha, those left, cannot be easily decomposed, guys. So it's also a problem. Okay, right? Wastage of jatropha, wastage of jatropha, wastage of jatropha, wastage of jatropha cannot be easily recycled. 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 But algal waste, right? But algal waste are good protein content. But algal waste are good protein content. But algal waste are good protein content. Okay, but algal waste are good protein content. So if algal waste are good protein content, so this waste we people can use as a fodder crops. So if cattle will take this food, so definitely it's a protein rich diet, their stamina will increase. Okay, their stamina will increase. So finally, what you got in this, on the basis of all this given information, that yes, alga is better than other options, other generations. And this is the reason, guys, alga have a good future. One more statement I'll tell you. So here, if farmer, Indian farmer involved into the growth of alga, so it's what? It is a economically viable options. Economically viable. It is a economically viable. Only, you know, the problem is only once. Only one problem is there. Those reaction, this we are going to perform, that is called TE. TE, technology, trans-esterification process. This is only difficulty here in this case. Neither in all the aspect, if you see, algas are better, guys. Neither in all aspect, algas are better, guys. So only trans-esterification process is difficult. Neither alga has the best option. Neither alga is the best option. Many questions are coming here. Definitely, sir. Algal blooms are there. Fishes problems are there, because you know eutrophication, BOD. You just tell me one thing, guys. You decide your purpose is the growth of fish. Yeah, your purpose is oil. If you will grow massive alga, I know very well, oxygen depletion and all in the environment, you people read it, guys. Okay. If you want both to equal, if you want both to equal, 50-50%, so you manage, you balanced. You manage, you people balanced. Okay, everyone, you people manage, you people balanced it. This is the, actually, guys, it is up to you what you want. Okay, I know, guys, very well that fishes will die. So you survive fishes, then why you are going for the algal based lipid productions? Why you are going set up this business? You set up the fish wala business. It is up to you. Yeah, you want to make a both balance, so you manage both entirely. Okay, I know very well this type of question will come, and finally this question came. I hope you understood, guys. Whatever you decide. Okay, but this is also one of the option, guys. This is also one of the options. And definitely here you will have a good income also in this case. If somebody don't like to do the fishes type of things in the water bodies, because they think so this is crime. Okay, we are going to grow a fish and we are going to kill them. So this type of people, for that alga is a better option. Somebody want, no, I will go the fishes and also for the algal production. You make equal in the balance. Don't do the massive growth of alga, neither the oxygen deficiency happen and fishes die. So you make a balance of your priority work, what you want. I hope you people entirely understand those statement I have given you here, guys, in this case. Okay, so it's entire concepts and biofuel portion over. Okay, now come next topic, and a new topic I will start today. It's called nuclear energy. Start nuclear energy. Nuclear energy. You start with nuclear energy. So is the protein from alga same as a single cell protein? Why you are asking the single cell protein, SCP? I'm not discussing the molecular biology. You just remember as a simple is a protein and protein is right. Okay, simple. Now come into nuclear energy. Now you come into the nuclear energy. This is the energy those providing 3% power generation in India, around 3 to 4% power generation in India. Overall, it is because of nuclear energy. So around 3 to 4% power generation in India is because of nuclear energy. Okay, it is a nuclear energy. Sorry, 4th generation biofuel. Sorry. Yes, Shoni. 4th generation biofuel. Sorry, you just write on 4th generation biofuel. Sorry. 4th generation biofuel. 4th generation biofuel is highly advanced. 4th generation biofuel is highly advanced. Again, I repeat, 4th generation biofuel is a highly advanced. Here, guys, genetically modified plants. Okay, genetically modified plants. Genetically modified plants. Genetically modified plants. and microbial fuel cell. Genetically modified plants and microbial fuel cells. Genetically modified plants and microbial fuel cells, okay, are the examples of fourth generation biofuel. Okay, genetically modified plant, what is it? This topic I'll discuss within the biotechnology class. In biotechnology, I'll tell you guys, after transferring of certain gene into the plant body, plant start to induce lipid formations. And this type of lipid formation into the plants, we will use for biodiesel production. But this discussion I'll tell you into the biotechnology experiment. Because through biotechnology experiment, we people can also generate biodiesel after transferring of certain gene. And this procedure I will discuss with you through recombinant DNA technology. It is possible we can transfer certain gene from one organism to the next organism. Okay, but here as an information you remember, because this is not the biotechnology class. Okay, through genetic engineering technology we can induces the lipid formation into the plant body. Yes, this is considered under the fourth generation, very advanced. Okay, but one thing I will tell you guys, in India, first, second and third generation is running, fourth generation not, because in India biotechnology research is not advanced. US involved into the fourth generation also. So your another question is, sir, which countries are using which type of generation? Depend on your resources, depend on your R&D, your technologies. So if you will ask me, sir, which generation India is working, so your answer is the first, second and third generation, because genetic engineering technology is not advanced. Okay, first, second and third generations. Okay, everyone, this is everything. Fine, this is everything. So it's a fourth generation biofuel. I finished here. Okay, fine. Microbial fuel cell, I told you guys during the discussion of fuel cell. So organic waste can be decomposed with the help of certain microorganisms. Organic waste can be decomposed by the help of certain microorganisms, and then they produce the H plus and electron minus. So that is also, you know, very advanced type of biofuel generations. Okay, so these all are the overall fourth generation biofuel. Yeah, now you come into the discussion of nuclear energy. Definitely, Abhinandan, you know, this is also one of the option that you are telling me. This is also one of the option you are telling me. And biodiesel production alga can be used for the sewage treatment. Definitely up to certain level it can be used also. Okay, but if you people will start to discuss the removal of polluting substances, then it will become as a part of bioremediation. Bioremediation, phytoremediation, microremediation, it was a UPSC question from the environment based. Even you people can also solve toxicity with the help of various microorganisms, with the help of various plant also. Then it will be the part of removal of pollutants. Okay, it will be the part of phytoremediation, bioremediation. But you wait, guys, I am discussing this time science and technology. You people have many questions, those are coming. I can understand because the topics are interconnected. That's why you people can raise your questions. And it is a genuine also. Now don't stop me, and I want to start a nuclear energy right now. It's very interesting topic. And literally you people will enjoy. Literally you people will enjoy. Okay, what is here in the case of nuclear energy? See guys, to come in nuclear energy, first of all I'll go into the basics. Okay, first of all I'll go in the basics. Okay, first I will go in the basics, and for basic I'll start from the atomic structure. And this chapter you read it in the 8th and 9th standard of books. Even 8th standard of NCERT book, in chemistry atomic structure is given. Okay, atomic structure is given. It is possible to produce a alga based biofuel, but what is our likely limitation of the developing countries to promoting this industry? Production of alga based biofuel is possible in seas only and not on the continents. 2017 prelim statement. Sir, this statement is incorrect. Yeah, is incorrect. Okay, Acha, you are asking me a question. Hirali. It is possible to produce alga-based biofuel. But what is the likely limitation of developing countries in promoting this? Production of alga-based biofuel is possible in the seas only, not on the continent. No, wrong. This statement is wrong. Because alga grow everywhere, not on the continents, everywhere. I told you guys, fresh water and ocean everywhere. So this statement is wrong. Hirali, you tell me this statement is right or wrong. You tell me this statement is right or wrong. You can find out very easily this answer right now, after my discussion. Okay, after my discussion. So start atomic structure. Start atomic structure. Just some basic. My question is, what about the unit in chemistry? What about the chemistry unit? Okay, what about the chemistry unit? Okay, what about chemistry unit? So in chemistry unit is the atom. In chemistry, yeah, everybody right. Agreed, everybody right. Okay, in chemistry unit is the atom. In chemistry, unit is a atom or elements. Acha, you tell me, this alga-based question is a current affairs or static? It's a current affairs or static? Okay. It's a general question, guys, common question. Okay, it's a general or common questions. Okay, fine. So atoms are element. Actually, according to Dalton said atoms are element is the basic unit of chemistry. But later on it is discovered like atom is not the simplest unit. Within the atom have a presence of electron and proton. So atom can be the smallest unit. And further it is proved not even electron, proton, neutron. Within the electron, proton, neutron have a presence of quarks, leptons type of things. Okay, quarks, lepton type of things. So that discussion I will do, guys. Okay, but quarks, lepton, muons, neutrinos, these all discussion I'll do under particle physics. You will literally enjoy that chapter, where I'll discuss Einstein general theory of relativity, where I'll discuss about the gravitational wave, where I'll discuss about the LIGO, where I will discuss about the LISA project. So a lot of discussion I'll do, but it will come under the particle physics, not here. Okay, fine. So, okay, fine. But according to Dalton, whatever Dalton said, atoms are element is the basic unit. You agreed this is the atoms are element is the basic unit. My another question is, how many elements are discovered? Okay, fine, 118, 120, 121, whatever you people do. It's not a question, I'm coming on the concept actually. Suppose 120 elements are discovered. Okay, fine, 120 elements are known. 120 elements are known in chemistry. My question is, these all the elements are naturally available? So my question is, these all the elements are naturally available? So answer is no, guys. Some of them derived also. Some of them derived also. All elements are naturally available. Some of them are derived also. I'll give you example. Uranium and thorium. These are naturally available. Uranium and thorium, these are naturally available. But plutonium, it is not naturally available. Plutonium derived after utilization of uranium. This plutonium derived after burning of uranium. So if plutonium not exists in the nature, it is left after burning of uranium into the nuclear waste. So it means, guys, most of the elements among these are naturally available, but some of them are derived. Why actually I am discussing these three elements? Reason, these three elements people discuss in the nuclear energy as a source of energy. These all are nuclear fuel. Okay, these all are nuclear fuel. So those elements we will use in nuclear energy as a nuclear fuel. Some of them naturally available and some of them is derived. So that is the reason here it is very, very important in the beginning. You must be clear. Okay, nuclear fuel, some of them naturally available and some of them derived through the help of atomic structure discussion. Okay, I am using only those which are very, very common. Cesium also there. Many of the elements are also there. But again, I tell you guys, read less and effective, crack UPSC. Read more and phaltujis, be a teacher. It's my philosophy. Okay, so to come on the point only. So here for you people, guys, uranium, thorium, plutonium, only important. So be rigid with the uranium, thorium and plutonium. Okay, be rigid with the uranium, thorium and plutonium. So elements or atoms are same, bacha, same. This element have their own atomic structure. So that is the reason elements you can call as atoms also. Okay, अब you people are suffering in the chemistry basic problem कि elements or atoms have a similarity or differences. Kindly read the 6th, 7th book, please. See, in the 6th book, atoms or elements are given. Okay, every elements have their own property. Every elements have their own property. Like, I would write something, suppose carbon 612. Carbon 612. The left hand side lower value, this is what? This is atomic number. Right hand side upper value, this is atomic mass. This is also called as a atomic weight. This is also called as a mass number. Many terms used for upper value, but lower one is called as a atomic number. Lower one is called as atomic number and upper one is called as atomic mass. So atomic mass or mass number, upper one, guys. So atomic mass or mass number, this is the upper one. Atomic number represent, I hope you people know very well, number of electron or number of proton. So atomic number represent number of electron or number of proton. Atomic number represent number of electron or number of proton. But atomic mass, this value, is the sum of proton and neutron. Okay, is the sum of proton and neutron. You people remember. This is the sum of what? Proton and, this is the sum of proton and neutron. Okay, proton and neutron. If I ask you guys, what about the number of electron and proton in the carbon? So you people will tell me, sir, 6 and 6. 6 number of electron and 6 number of proton in carbon. And if I ask you guys, what about the number of neutron in the carbon? So definitely you people can tell me, sir, p value I can find out from the downside value at 6. So n is equal to what? 12 is equal to 6 plus n. So n is equal to again 6. So through the help of atomic number and atomic mass, you can provide the information about number of electron, number of proton and number of neutron. Those are present inside the atoms. Those are present inside the atoms. Okay, those are present inside atoms. Okay, those are present inside atoms. Okay, those present inside atoms. Okay, one thing more. If I do the addition of neutron, if I will do addition of neutron, if I'll do addition of neutron plus n 0 1, so what will be the changes in the carbon? I just say, guys, suppose I mention carbon. So carbon is denoted by lower side left hand some value is written 6 and upper side some value is written 12. This lower side of value is called atomic number. Atomic number represents number of electron and number of proton. But atomic mass, the upper value, okay, it represents the sum of proton and sum of neutron. Okay, I just ask you guys, I hope you people know very well, through the help of atomic number, atomic mass, you can find out the number of electron, number of proton and number of neutron. Okay, just this discussion I have done. Kindly read the 6th standard book, please. Electron, proton, neutron and the atomic mass, atomic numbers are given there. And one thing more. I think 6th, 7th, 8th standard book, it is everything is there. I just told you guys, if I will do the addition of neutron in the carbon, so what about the changes are there? You have a common sense. Neutron is upper side. So if one neutron I will add, to upper value increase, it will become as a 13. Okay, it will become as a 13. And I hope you people know very well, if this 612 will become as a 613, so here atomic number are same, but atomic mass vary. This is the reason these two are what? These two are isotopes. These two are what? These two are isotopes. Okay, so isotopes are what? If atomic number same, atomic mass varies. And isotopes are very, very important in this chapter. You know, by changing the number of neutron, property of 612 and property of 613 both change. Only by changing the one number of neutron, these both two property changed. Actually, those chapters I am going to discuss with you nuclear energy, various isotopes I will use, like uranium 92 238, uranium 92 235, uranium 92 234, uranium 92, 233. Many isotope of uranium I will discuss here. So many isotope of uranium I will discuss here. Similarly, plutonium 239. Similarly, plutonium 240. So many isotope I will discuss. Even hydrogen isotope I will also discuss here, like 1H1, protium, like 1S2, deuterium, like 1S3, tritium. And this discussion I will do during the ITER reactor, 1S2 plus 1S3. In that case, I will discuss deuterium-tritium fusion by 2034. So I hope you understood. Isotopes I'll discuss here. Isotope I can tell you in a very simple way, more than one form of the elements. And how isotope define, how isotope differ, it is on the basis of changing the number of neutron. If you people do the changing the number of neutron, okay, what happened? Our element will come into the another form. An element will go into the another form. So atomic number same, atomic mass vary. Okay, atomic number same, atomic mass vary. Now come another point here. Okay, this is here. One thing more, guys. One thing more. Atomic number is the identity of every element. Atomic number is the identity of every element. What is the meaning of this statement? Again I repeat, atomic number is the identity of every element. How it is? See, guys. Okay, isotopes means more than one form of elements. Okay, Natasha and Sahana never read in their own life chemistry. Because if isotopes anybody will ask me, it means you never read the chemistry, atomic structure. Kindly read the 8th standard book, please. It's my humble request. Because sometimes you people ask me, suppose I am discussing the cell biology, and if anybody asks me what is a cell, so it show what? In your background you never read the book. Even everywhere it is written. Suppose you read and you forget. But still in the UPSC preparation, anywhere if you go, it is mentioned, start NCERT book. It means you still not revise your NCERT book. So please, don't be fast. Okay. You read everything entirely in the proper way, neither you will suffer. Okay. Even everywhere it is written, guys. First of all, you clear your basics. And it literally UPSC asks basics. Okay. I'm just telling you guys, each and every elements have a specific atomic number. An atomic number is the identity of every element. Atomic number is the identity of every element. As simple I can tell you, hydrogen is the first element. Why hydrogen is the first element? Because it's atomic number 1. Helium is the second element, atomic number 2. Lithium is the third element, atomic number 3. Beryllium is the fourth element, atomic number 4. Okay, fine. This is what? Hydrogen, helium, lithium, beryllium, boron 5, carbon 6. Please don't tell me the name of element. Not required here in this case. In that way, guys, I will reach somewhere where the atomic number will be 82, then 83. And somewhere I will reach finally as a 118th element, 119, 120th element. So if I ask you which one is a 118th element, the simple answer is those elements have a 118th atomic number. So which one is a 118th element? Those element atomic number is a 118, that is a 118th element. It is a smart answer. Here the name of element is not required. When it was required during 9th, 10th, 11th, 12th, you did not prepare. Here it is not required, so you are going to mug up the name of element and then atomic number. You are wastage your energy. Okay, so what is here? 82, 83. Now simple. Which one is the 82nd element? You have a very intelligent answer. Those elements have 82 atomic number. Simple. Those elements have a 82 atomic number. Now come here, guys. Actually, after 82 atomic number, there is some specific property which are present in most of the elements. And this property is called as a radioactivity. This property is called as a radioactivity. After 82nd atomic number, most of the element have radioactive property. Radioactivity. And due to radioactive property, these elements are called as a radioactive element. These elements are called as a radioactive element. These elements are called as a radioactive elements. Now question is, so radioactivity property, okay. Radioactive elements. Okay, now tell me. Okay, definitely you people can ask me, sir, now tell me what is the radioactive property. See, radioactive element means these are unstable element. These are unstable element. This is the property of radioactive elements. So what is the property of radioactive element? Radioactivity. Radioactivity means instability. Radioactivity means instability is here. Instability is here. Radioactivity means what? Instability is here. See guys. So radioactive elements are unstable element. In the free form, guys, they are creating massive energy. They are very dangerous. Radioactive elements, just like I'll tell you guys, radioactive elements are unstable like a mad person. You tell me, mad person is free? No sir, mad person is already arrested somewhere in the house. I hope you know very well, guys. We will never allow the mad person go outside. Neither the mad person is dangerous for everyone. That person is unstable. Similarly, try to understand radioactive elements are the mad elements. Okay, so mad elements should not be in the free form. Definitely you can ask me, sir, what is the meaning of free form? Actually, those radioactive element discussion I am doing, uranium, thorium and plutonium, those we are using here as a nuclear fuel. Here petrol, diesel not burn. Here LPG, CNG not burn. What will burn here in the nuclear energy? Nuclear fuel burn, like uranium, thorium or plutonium. And these uranium, thorium or plutonium are what? These are radioactive element. These are unstable element. You know, uranium present in the nature in the form of pitch blende. In the form of pitch blende. Thorium present in the form of monazite soil. Within the monazite soil, what we are doing? In this pitch blende, uranium present, it is safe. In this monazite soil, thorium present, it is safe. Okay, but when I make free this plutonium, this thorium, then they are very, very reactive in the free form. So this is the house where uranium present, this is the house where thorium present, but when we separate the uranium from the pitch blende and this thorium from the monazite, okay, they are in the free form and they are emitting various radiation like alpha, beta and gamma. I hope you know here the gamma radiation, its penetration power is very high. It affects your body. These all radiations are invisible, but they can harm your genomic sequences. They can create a cancer and many problems. So this is the reason, guys, these radioactive elements are very, very dangerous. And why we people are using uranium, thorium, plutonium? These are radioactive, these are unstable, and because of unstable, these are highly energetic. Very powerful elements. Okay, very powerful element. These are highly energetic, or I can tell you these are very powerful element. Okay, very, very powerful element. So this concept I hope everybody clear. Okay, this concept I think everybody clear here. Now come. So I'm going to erase it. So what about the fuel we are using here? Sir, uranium, thorium or plutonium. These fuels are radioactive elements. These properties are unstable. Because unstable, they are very energetic. They are very, very energetic. So this type of fuel we can use to develop an atom bomb. This much of energy they have. But the procedure is something different. How this fuel will use for atom bomb, how this fuel will use for hydrogen bomb, the methodology is different. The procedure is different. I hope I simplify the thing, guys. Basic problems. Those you have always. I simplify the things. Because I told you guys, I start my classes, every chapters, I start from the 0 level. Okay. So non-science and science, everybody understand very well. Even science students also have a basic understanding. Non-science though, they have not basic, mostly. But the science have also basic problems. So everybody will come up to the UPSC level, what is the requirement. Okay, so I describe you the meaning of instability. Instability means pagal, mad elements. In that way, try to understand. In the behavioral term, I can tell you these are the mad elements. Okay, now, one more statement, guys. One more statement. Atomic number represent number of electron. You have seen? Atomic number represent the number of electron. I just said if atomic number is going to increase. So what about the number of electron is going to increase? If atomic number is going to increase, what about the number of electron is going to increase? Okay, number of electrons is going to increase. What is here? You just see, guys. If I am telling you one atomic number, 1 electron, 2 atomic number, 2 electron, 3 atomic number, 3 electron. You know those elements I am telling you like uranium, thorium and plutonium, they all have a more than 82 atomic number. I told you na guys, 82 atomic number, 83 atomic number, then 118th element. So uranium, thorium, plutonium are here, guys. If uranium, thorium, plutonium have a more than 82nd atomic number, so they have a more than 82 number of electrons. They have more than 82 number of electrons. I hope common sense and you can understand. In the school time, I hope you people have seen when the number of electron is going to increase, what about the size of atom increases? In a school time, I hope you remember. Your teacher taught you. This is nucleus, have a proton and neutron. First orbit, 2 number of electron. Second orbit, 8 number of electron. Maximum 8 number of electron. Third orbit, 18. Fourth, 32. I'm just telling you guys, as just the number of electron is going to increase, what about the size of atom increased? So what about the conclusion here? Here in this conclusion, I can tell you uranium, thorium and plutonium are large size of atom. Because they have a 82 plus number of electron. So of course their size of atom will increase. If you people have a more number of people in your house, so definitely your house size will be bigger. Rather where you will adjust the people, guys. Difficulty. So similarly, more number of electron. What you will say about the size of atom? It's bigger in size. So what about the conclusion? Conclusion is here, uranium, thorium and plutonium, they are large size of atom. In this way we can represent in the reference of nuclear energy. If you guys are facing a buffering somewhere in your side, so don't worry. Still the video will upload here. Already here, you people can also see. So don't worry. Okay, the problem may be your side. Because sometimes this issue happen. Okay, suddenly, you know, internet can drop also. It's a technical fault, it's possible. Same it happened in the early morning with me. That's why I been late for just again 20-30 minutes. I late there. Okay, it's a technical mistake that is possible anyone's side. But don't worry, I think the video is going to upload here on the sites. Okay, for certain period of time you people can see that videos. Okay, fine. So connect with me, guys. So I think you people understood uranium, thorium and plutonium are the large size of atom. Everybody clear? Yeah, bigger size of atom. Okay, fine. If an atom size will be more big in size, so what about nuclear size? Also big. It is a concept you remember. If size of atom is bigger, so on the inside the nuclear size will also be bigger. I hope in the school time your teacher taught us this type of atomic structure. But nothing more required. It is enough. Now you come into the nuclear fission. Okay, great, Muskan. All okay. Fine. Okay, fine. Nuclear fission. Come nuclear fission. Come nuclear fission. Come nuclear fission. Nuclear fission. Right? What is nuclear fission? Breakdown of large size of atom or nuclei, right? Breakdown of large size of atom or nuclei. 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 Breakdown of large size of atom. If large size of atom, so its nuclei also large size. I hope you understood. So breakdown of large size of nuclei or atom into small size of nuclei or atom. Into small size of nuclei and atom. Nuclei NuClei. Into small size of nuclei or atom. Into small size of nuclei or atom and energy generate. And energy generate. That is fission energy. And energy generate, that is fission energy. And energy generate, that is fission energy. Okay, and energy generated, that is fission energy. What will come here in this fission energy? See guys, write down the equation, which is very, very important. Okay, but before going to write the equation, write down the examples. Example of nuclear fission energy, right? Atom bomb. The one example you write, that is called atom bomb. The one example you write, this is atom bomb. The one you write, this is atom bomb. And second example you write down, nuclear energy development program of India. So one is the atom bomb, and second you write nuclear energy development program of India. Okay. So one example is the atom bomb, and second is a nuclear energy development program of India. Now write down the equation. Write down equation. It's a uranium 92. This uranium break in the presence of neutron, and then it form barium 56, and then it form what? Krypton 36 plus 3 neutron and plus heat or energy, and plus heat or energy, and plus heat or energy. It's a nuclear fission reaction. You just note down first, guys. You just note down. So large size of atom or nuclei. Breakdown of large size of atom or nuclei. Okay, breakdown of large size of atom or nuclei. Okay, into small size of atom or nuclei, and energy generate. And energy generated. So large size of atom or nuclei is going to break into small size. So 92 atomic number, 92 number of electron, more bigger size. It's going to break into 56 and 30 small sizes. So large size break into small size. In this case, this heat or energy generation happen. Okay, this heat or energy generation happen. It's a fission. Example, two example you have seen. The one is an atom bomb, and second you have seen India's nuclear energy program. Those will be my entire discussion today, guys. India's nuclear energy development program, those will be my entire discussion today. I will come there. Wait. Okay, nuclear fission. Now come next, that is called nuclear fusion. Come next, nuclear fusion. Come next, nuclear fusion. Nuclear fusion, right? Nuclear fusion. Nuclear fusion. Very small size of, right? Very small size of atoms and nuclei fuse together. Vice versa feature of nuclear fission you will see in the case of nuclear fusion, right? When a small size of nuclei or atom fuse together. Very small size of nuclei or atom fuse together. So when a small size of nuclei or atom fuse together and form a large size of nuclei or atom. Okay, when a small size of nuclei or atom fuse together and form a large size of nuclei or atom. And form a large size of nuclei or atom and energy generate. And further what happen? And heat or energy generate. And heat or energy generate. That is fusion energy. And heat or energy generate, that is fusion energy. So and heat or energy generate, that is fusion energy. Okay, and heat or energy generate, that is fusion energy. Example, write down hydrogen bomb. Hydrogen bomb. Hydrogen bomb. Okay, next write down sun energy, solar energy. Natural sunlight, I am telling you. Natural sunlight, those are coming towards the ground. It's a result of nuclear fusion. Nuclear fusion. And one more write down about artificial sun experiment. Those discussion I will do. Next, artificial sun experiment. And next one is a artificial sun experiment. And next one will be the artificial sun experiment. Okay, artificial sun experiment, here in bracket you write down, that is called ITER. So what is the ITER, International Thermonuclear Experimental Reactor? As a separate topic I will discuss. This is an important topic. This is the important topic. International Thermonuclear Experimental Reactor. In this reactor, those experiment will perform. It is based on nuclear fusion. So it is a nuclear fusion experiment. It is a nuclear fusion experiment. Okay, everyone. Equation, you write down equation. 1s2 plus 1s2. It formed 2He4 plus heat or energy plus heat or energy. 1s2 plus 1s2 is equal to 2He4 plus heat or energy. 2He4 plus heat or energy. This is everything. Write down. 1s2 plus 1s2 is equal to 2He4 plus heat or energy. It's what? It's a hydrogen isotopes. Even 1H1, 1H2 plus 1H3 is also there. Again have some heat or energy generates. Okay, but you people understood small nuclei or atom fused together, atomic number 1 and form a large, definitely larger, 1 to 2 is larger. Okay, so what is again heat or energy generate? That is nuclear fusion. That is nuclear fusion. Okay everyone, fine. That is nuclear fusion. And 3 examples you have written. The one hydrogen bomb, second is the sun energy, sunlight, and third is the artificial sun experiment. Hemashri, I understood why you ask it like China's artificial sun. See, actually energy based all current affairs I will take together. Throughout the year, what was the current affairs? Okay, so finally static and currents both will merge together. Wait Hema, I'll discuss with you. Okay, I'll discuss with you. Fine. Okay. Now come into the comparison. The one side nuclear fission. The one side nuclear fission. And second side is the nuclear fusion. So nuclear fission and second side is the nuclear fusion. So one side is nuclear fission and second side is nuclear fusion. So nuclear fission and nuclear fusion. So what about nuclear fission and nuclear fusion? See guys, nuclear fission. Comparison, I'm telling you, comparison. What happened in nuclear fission, nuclear fusion, example of nuclear fission, nuclear fusion, you people know very well. See comparison. If I ask you in these both two guys of nuclear fission and nuclear fusion, in which process have a more heat or energy generations? So remember nuclear fusion is them. More heat or energy generation. More heat or energy generation. So more heat or energy generation happen in the case of nuclear fusion. But in the case of nuclear fission, comparatively less. Nuclear fission have a comparatively less heat or energy. Have a less heat or energy. Okay, comparatively less heat or energy. The nuclear fission have a less heat or energy. And what about nuclear fusion? Comparatively have a more heat or energy. So comparatively have more heat or energy generation here. So more heat or energy and less heat or energy. Second point guys, when the nuclear fission reaction happen, when nuclear fission reaction happen, it generates lot of nuclear waste. And nuclear waste is also not good. This one have a lot of radioactive elements. Those can be dangerous. This is the reason its recycling is very important. And I will discuss in later on about the reprocessing plant. The use of reprocessing plant where the nuclear waste will go and recycle it. Where the nuclear waste will go and recycle it. Okay, where nuclear waste will go and recycle it. Next point. In the comparison of nuclear fission and nuclear fusion. Come here guys. So in these both two aspects, what you got? Here the nuclear waste, no, are low. Overall, no guys. Overall, no nuclear waste here in this case. Okay, overall, no nuclear waste here in this case. So nuclear fission and nuclear fusion I described. So in these both two aspects, what you got? In these both two aspects, you got nuclear fusion is better than nuclear fission. Of course. Nuclear fusion is better than nuclear fission, but still guys have one problem. And that is a major problem with the nuclear fusion. And what is a major problem? So here I'll tell you only one limitation, and that is a major problem. Limitation with the nuclear fusion is what? It is uncontrolled reaction. It is uncontrolled reaction. It is uncontrolled reaction. This reaction is uncontrolled. That is the reason guys, this artificial sun experiment research ITER reactor not started properly. China, other countries are doing a small level of work, and then all the work will integrate together, assemble together, and then in the southern France, Cadrec is the area where the ITER reactor will start. So those China has done, it was just a small research for the ITER in the coming future by 2034. For this time, this is enough, and the rest of other discussion I will do under ITER reactor. Rest of other discussion I will do under ITER reactor. Wait. Okay, here. This is controlled reaction. It can be controlled, guys. This can be controlled. It is the controlled reaction. We can control it, and that the technology of how to do the control of nuclear fission reaction, we people know very well. That's why it cannot be very, dangerous. If the question will come that no waste generates in the case of it, so better here I'll tell you guys, no is fine. No is fine. You want forcibly answer, so better no is fine. Low I will remove it. No nuclear waste is here. I forcibly telling you no nuclear waste is there. Okay, Mahak. And definitely, just one of the guy, Shrikant asked me about higher temperature and all, it can be produced as a plasma type. Definitely. You know what is a plasma? Is a fourth state of matter. The first state of matter, solid, second is a liquid, third is a gas, and fourth is a plasma. And the fifth state of matter, I just wanted to see that anybody know which is discovered and identified as a fifth state of matter. Plasma will generate, guys, when the gases will burn at very high temperature. Then the gases will ionized. Solid burn become liquid. Liquid burn become gas. Gas burn, it will be ionized gases. And ionized gases are called as a plasma. Ionized gases are called as a plasma. Ionized gases are plasma. Okay, Shrikant. Yeah, you people are right. This is Bose-Einstein condensate is the fifth state of matter. Absolutely right. Bose-Einstein condensate is the fifth state of matter. And Bose-Einstein condensate I'll discuss under the particle physics. Agreed, guys. You people are right. Very good. Very good. Very good. Very good. So it's a comparison of nuclear fission and nuclear fission. I'm expecting this question in your paper, guys. It is a good question. Comparison between the nuclear fission and nuclear fusion. So I'm expecting this question in your paper. Comparison between nuclear fission and nuclear fusion. I think today I can continue your class till 11:30. Nobody will have any problem. Because around 30 minutes, 25-30 minutes around, I was late because of technical fault. Okay. So I think you will not have any issues. Because my next class is at 12 o'clock. So I have a proper time. So I can finish your class at 11:30. If you people have not any classes in that cases. Okay, and you guys will comfortable. And officially I got a message that if you shouldn't have a need of it, so I can give a 5-minute breaks. Okay, so because till last day I did not receive the message. I think somebody's even discussed with the management, but I got this message. If you will have a need of breaks, so I can give you 5 minutes only. Okay, I think most of you people got a smile on the face. But I'm able to take a class at least 8 hours, 9 hours. I don't have a problem. When I need a tea and coffee, even morning I start at 6 o'clock and night I stop at 8 o'clock. Just the room is going to change. No break is there. Tea and coffee is something I take in the class. Juices वगैरह I take in the class and continue my classes. Because I never take an exertion during the classes. Actually, I feel better in the class. Because I think so that I'm literally involving and doing something. I'm not wasting my time when I'm taking my classes. Okay, when I sit outside, then I feel I'm wasting my time. Okay, so I'm happy to be in the class. It's a pleasure to me, guys. It's not just a formality I'm doing. It's a passion, that's why I joined it. And that is a good, guys. A part of passion you are also earning. So how beautiful it is. Mostly I have seen the people are doing a job because for earning only. Not enjoyment. But for me, is enjoyment, fun, and earning simultaneously, parallelly also there. So how beautiful the job is for me, I'm telling you. Okay. So, yes. Now come into another discussion. Nuclear Energy Development Program of India, right. So no break is required, and even please give daily prelims and mains questions. For daily prelims and mains question, guys, I told you with me you will see the question papers. Daily you people solve UPSC question paper. Actually listen, one part that I did not say. You want to solve real question paper of your UPSC examiner. Yeah, you want to solve the question paper those many students are making, many people are making. So definitely you will tell me, sir, I want to solve the real question paper that UPSC examiner made. The market based the question paper is available. I know, guys, that is freely available. You people can take a test series and solve it. Okay, but first you people start to solve real question paper. Actually, it's my own experience that you should try to learn UPSC mind. First of all, UPSC mind. What he thinks, how he generates questions, how he try to confused. If you will start to read the examiner mind, so definitely, guys, next time it's my confidence you will never fail. And for that purposes, I advised. You will not believe me. I specially solve UPSC question papers, and I still love to solve UPSC question papers. Reason, I just try to think like how examiner thinking is. If I will read the examiner thinking, definitely I will take my better classes, and you will get the result directly. Maximum question you will get it. So this is my humble request. You people solve that UPSC question this much of time. That question you remember with a year, like me. Not in my subject, in every subject. And after it, you have already inside test series. As last you start to solve the NCRT, the inside test series. So ultimately, your whole completions will, your preparation will complete. I will never suggest you go and solve many question papers. But inside current affairs you are following, inside question paper you follow, test series as you follow. It will be integrated approach. Me, myself, classes you are listening, and a part of it, what you will do? Classes, then question paper you solve. So you keep everywhere in your preparation in uniformity, not in different dimension. You keep everything in uniformity. So you will not suffer, guys. I hope you understood, guys. But again, I repeat, guys, like you people solve UPSC question paper, and within the book, guys, I have given entire questions. And in the last, I have given the mains question paper also, and even their solutions also. And a part of this last 30 years mains question paper is also compiled in various subjects. So kindly see it, guys. So yeah, now come Nuclear Energy Development Program of India. Okay, Nuclear Energy Development Program of India. So after reading it, this Nuclear Energy Development Program of India, okay, then I'll give you at least 5 minutes break. Don't worry. So right, Nuclear Energy Development Program of India. But my suggestion is, guys, you people solve UPSC question paper. Because the real question paper you people solve, na, you will learn a lot. Examiner mind. And you will literally understand about my mind also. Why my way of teaching is like this, why I'm discussing like it, everything. Why I brought this type of topics, you will get it. So Nuclear Energy Development Program of India. I hope you people heard the name of Homi Jahangir Bhabha. This man name, I hope everybody heard it, Bhabha. You know, India's Nuclear Energy Development Program was made by Bhabha, right? Bhabha made, M-A-D-E. Bhabha made, M-A-D, Bhabha made 3-stage Nuclear Energy Development Program of India. Bhabha made 3 stages Nuclear Energy Development Program of India. Bhabha made 3 stages Nuclear Energy Development Program of India. So Bhabha made 3 stages Nuclear Energy Development Program of India. And one more point you people know very well, India's nuclear energy program is based on nuclear fission. That answer you people also know very well. Okay, right? No need to write it, I think. Because in nuclear fission, you already have written nuclear program of India is based on nuclear fission. I'm now directly coming into the stages. Those Bhabha told you. According to Bhabha, the first stage Because most of the places, guys, you will get this type of article. India's 3-stage nuclear energy development program. India 3-stage nuclear energy development program. Today you will listen what actually the 3-stage nuclear energy development program. So first stage nuclear energy development program. First you write about the fuel, then moderator, then coolant, then reactor. It's a first stage fuel, moderator, coolant and reactor. It's a first stage moderator, coolant, fuel, moderator, coolant and reactor. Then you come into the second stage. Here one line information I'll tell you. As those I am doing here, you people also follow. Same fuel F, moderator M, coolant C and reactor R. Here I'll tell you about the third stage. Again fuel, moderator, coolant and reactor. Now listen the name, guys. Those fuel, moderator, coolant and reactor we people are using here. You see name. Okay, now come. Which fuel we are using here? Of course, natural uranium. But normally we are not using natural uranium directly. So what actually we are doing before going to use it, that discussion I will do. Natural uranium. Moderator and coolant is the D2O. D2O means heavy water. You just write it is a heavy water. So moderator and coolant, that is a heavy water. Reactor is what? It is a PHWR. PHWR means pressurized heavy water reactor. This is pressurized heavy water reactor. Next one. Fuel is the plutonium here. The symbol is Pu. Moderator rarely use. Coolant is the liquid sodium. Reactor, breeder reactor. Fuel is the thorium in this case. Moderator and coolant. Moderator is the light water. Light water means demineralized water. So moderator is the demineralized water. Coolant is the heavy water. And the reactor, still you can write breeder reactor. Yeah, it's also written like advanced heavy water reactor. So breeder reactor you can also write. Still in the breeder reactor have different types. You just note down all the names. You just write. So different types of moderator, coolants and all we are using here. I hope you people clear. Okay everyone, so it's a stages. I hope you will remember. And now after 5 minutes I will continue. First about the fuels, all the stages. Then we'll go about the moderator, all the stages. What is the purpose of coolant? What about the reactor? And then one more discussion, those are not given here, like mm, a control rod or absorbent rod. I'm expecting control rod or absorbent rod for the next year of your paper, 21, 22. So that discussion I'll do. So timing is 9:58, and I will come here at 10:03. Hello, hello. I think I should start now. Okay, great. So first you give a heading about fuel. So first you give a heading about fuel. So first you give a heading about fuel. See, here in this fuel we start from the first stage fuel. The first stage fuel. So first stage fuel. First stage fuel. What will come in the first stage of fuel? Okay, see guys, 1780s. 1780s was the timing, guys, when uranium was discovered. One of the German scientists, chemistry background, his name was Martin Klaproth. His name was Martin Klaproth. This man discovered uranium in pitch blende. In pitch blende. So this man discovered uranium in pitch blende. Pitch blende is what? It is a kind of uranium ores. So discovered uranium in pitch blende. Pitch blende is the uranium ores. Pitch blende is the uranium ores. Okay, everyone. In this uranium ore, Martin Klaproth got presence of uranium. And there is the story, guys, behind the nomenclature of uranium. Just few years back, one of the planet was discovered, Uranus. And the look and appearance of uranium was very similar to Uranus. That's why the name was given as a uranium. So uranium name actually came from planet Uranus. Okay, in this pitch blende, where the uranium ores, uranium present, total 6 isotope of uranium was there. So within the pitch blende, total how many types of isotope was there? 6 isotope of uranium was there. 6 isotopes of uranium was here inside. What was these isotopes of uranium in the pitch blende, guys? You see, uranium 238, uranium 235, uranium 234, plus dash. These are total 6 isotopes. Actually, I need some space for second stage fuel and third stage fuel. That's why I try to adjust here this side. Okay, uranium 238, uranium 235, uranium 230, everywhere the atomic number 92, 92. I hope you know very well, guys, atomic number same everywhere. So differences only on the basis of atomic mass. But 3 isotopes, why I could not mention? I'll tell you the reason, guys. Don't think so, sir, I have given the complete fees, but still you are not giving the complete information. There is nothing like it, okay? You wait. Why the reasons uranium 238, 235 and 234? I'll tell you the reasons. Okay, what is here? Come. The percentage of uranium 238 is 99.2742. Here 0.7204% uranium 235. So uranium 238 99.2742. 99.2742. Here the percentage 0.7204%. If you go in uranium 234, it's what? 0.0054% around. So if you sum all the 3 values, you will get around 100%. If you sum all the values, you will get nearby 100%. You will get as a nearby 100%. So this is the reason, guys. This is the reason these three isotopes names are given everywhere. These isotopes names are given everywhere. Okay, these isotopes names are given everywhere, and you people also remember. Now one thing more, guys. Actually, nuclear energy we can use for two purposes. Nuclear energy we can use for two purposes. The one for constructive uses, electricity generation. Second, as a destructive uses, atom bomb formation. So there are two uses of nuclear energy are possible. The one is for constructive uses, electricity generation, and second is for destructive uses, atom bomb formation. Both two uses are possible, guys. And the same fuel we use, uranium. And here there is something which is very, very important. If you want to use uranium, so you must have to enrich the uranium. Here I am telling you one of the processes that is called enrichment. Enrichment is very, very important. You must have to enrich uranium. And this uranium will be 0.7204 will reach 3 to 4%. When this uranium will reach 3 to 4%, it will be utilized for electricity. So 3 to 4% uranium, it will be used for electricity. This much of enrichment. But your purpose may be of atom bomb. If you want to use the atom bomb, so this enrichment should go 90%. 90% it will be utilized for atom bomb. So what you have seen, guys, enrichment percentage of uranium-235. Again, I am telling you, enrichment percentage of uranium-235 I am doing only. I know you people have many questions right now. Sir, why uranium-235 we are using there, guys? Actually, there is reason. In conventional reactor for power generation, okay, whenever the scientists have done the experiment, they got uranium-235 is the better fuel. For breeding experiment and all, okay, breeding reactors and all, okay, that uranium-233, 38 we can also use. But again, I'm telling you guys, the best uranium in the reactor for electricity and even for atom bomb, that is uranium-235. It's a part of research. So we are not going to do the research. You just remember uranium-235 is better among all. And uranium-235 based technology also developed, because every element and isotope have their own property, and here uranium-235 is best among all. Because I know you people can chat and message me, sir, why it is so, even this concentration level is very high, but why we are using it? Reason, it's chemical property. I told you guys the atomic number change, number of neutron change, property change. See how much that this much of property change in uranium-235. So in the first stage, actually the fuel is what? Uranium-235. And see very well, guys. See, you must be clear. India know very well how to do enrichment. Enrichment technology every countries never know. Okay, but India know very well. But the problem is India has not the uranium actually. The problem, India has not the uranium. This is the problem, India has not the uranium. So this is the reason India is dependent for the uranium on other countries. In the nuclear diplomacy chapter, I will discuss in detail. So I hope this concept you people very clear. So problem when India will access the uranium anyhow, then through the help of enrichments, we can change the percentage of uranium. Enrichment type of concept I have also discussed with you during the discussion of methane. I told you 40 to 60% methane is enough for cooking purposes, but if 90% enrichment go, this methane will utilize for CNG. I hope you remembered. So I have given you this planning already earlier during the discussion of methane enrichment. The same I am telling you here, uranium enrichment. Enrichment of uranium change, purpose of uranium change. One side it will be electricity, second side it will be atom bomb. This much of purpose can be changed, guys. I hope everybody understood, and you people will give me response, sir, understood. So don't be confused here, guys. So parallelly I am discussing you electricity generation and atom bomb formation, both together. Okay. So now we'll come into the second stage. Great, guys. Great, 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 great. The students are literally very nice here in this class. Okay, nice here in this class. Literally, they can understand most of the things. Okay, really, I have seen the queries from your side. I'm so happy to see it, guys. Okay, it's nothing, it's just experience, because I know very well from which topic, how many questions, how much the question student can raise. Accordingly, I already have discussed everything in the class. So it's nothing. I'm very talented and all. It's just experience. Those I have discussed in the last 20 years. That every discussions, experience, I just club together. And that's why today I have no questions. Really have a questions. Okay. So second stage. Second stage, what about the fuel? Second stage fuel, you people know very well. It is a plutonium. But you just wait about the plutonium. First of all, I'll go into the nuclear fission reaction. Nuclear fission reaction, I hope everybody remember. So what was the nuclear fission reaction? You know, uranium-92. Break in the presence of neutron. Form barium atomic number 56. Barium. Krypton, the atomic number 36. 3 neutron generate and plus heater energy. I hope you guys remember. And heater energy. I hope you guys remember. So uranium break in the presence of neutron, form barium, krypton, 3 neutrons, and heater energy generate. And heater energy generate. Okay, and heater energy generate. Okay, everyone, what will come here? What is the source of plutonium? I told you guys plutonium not exist in the nature. So definitely, what is the source of uranium? Very simple, guys. When this reaction perform, here some nuclear waste also generate. Here's nuclear waste also generate. Actually, in this nuclear waste have a plutonium. And you know which plutonium is here? Here the plutonium is plutonium-239. Here plutonium is plutonium-239. So which plutonium is here? Plutonium-239 is actually under the nuclear waste. So I can tell you plutonium-239 is not naturally available. It is derived after burning of uranium in the reactor. So plutonium-239. Okay, plutonium-239. This is the plutonium-239. You remember, guys, plutonium-239. But one thing I'll tell you. Plutonium-239 is highly unstable. This is a property. Plutonium-239 is highly unstable. And due to high instability of plutonium, it cannot be used for electricity. It is utilized for atom bomb. It is utilized for atom bomb. But if you people want electricity, so what you must have to do? Do one thing, guys. You people do the addition of neutron. You people do addition of neutron. And you know very well, guys, when you people will do the addition of neutron, this plutonium-239 will become as a plutonium-240. And plutonium-230 will be comparatively what? Comparatively less unstable. This is comparatively less unstable. And the less unstable nature will be utilized for electricity generation. It will be utilized for electricity generation. It will be utilized for electricity generation. So in this way, guys, plutonium-239 that will convert into plutonium-240. So atom bomb and electricity. I hope no one have a doubt, and I hope you understood why in the basic discussion I told you addition of neutron change the atomic mass, because at that moment of time I was a plan of this discussion, and those I am doing here right now. Okay, so plutonium made atom bomb, plutonium made electricity, both are possible, but different isotopes. But different isotopes. Okay, but different isotopes. Okay, fine. Now coming to the third stage. Okay, third stage. So I hope you have written it. Now third stage. Third stage. Third stage. What about the fuel in the third stage? You people have seen it was thorium. So I will write directly thorium. But you people know very well, thorium not exists in the nature. Actually directly. It is in the monazite soil. So within the monazite soil, First of all, we will separate a thorium. We will take a thorium. From the monazite soil, we will take a thorium. Okay, we will take a thorium. And now this thorium, okay, will be used. But one thing, mostly students confuse with this thorium. We people never use thorium directly as a source of energy. Yes, we are doing some reaction. What kind of reaction we are doing? Listen guys, this thorium, we are doing the addition of neutron and removal of beta particle. This is a lab work. In laboratory people are doing. If addition of neutron and removal of beta particle will do, if addition of neutron and removal of beta particle we will do, then this thorium will convert into uranium-233. But again, I remember I am telling you guys, this type of reaction is not required for your paper. But you must be clear. Guys. You must be clear, guys. Those third stage fuel we are using, it is the thorium derived uranium-233. This is thorium derived uranium-233. That is very, very important. So in the third stage, what about the fuel? Thorium derived uranium-233. It means uranium-233 not exist in the nature. Definitely not. You see here all the 5, 6 isotopes. Yes guys, uranium-233 not anywhere. Uranium-233 only came from thorium. It means in the third stage, we never use thorium as a direct fuel. Actually, firstly, we convert the thorium into uranium-233, and now uranium-233 will become as a fuel sources. So now, what about the conclusions? If I'll ask you about the electricity generations, in the first is uranium-235, 3 to 4% enrichment, fuel. In the second stage, plutonium-240 is a fuel for electricity. In the third stage, thorium-derived uranium-233 is the fuel. Ab you tell me guys, you have an entire information or not? My support was here required and I discussed with you. My support was here required and I discussed with you. I want everyone answer yes. Ab now no one can confuse you. Even examiner, yeah, no one in your discussions. You people can properly even define about the stages of fuels. You just note down guys, everything is very clear. And even why I mention all three parallelly, at least you will see the comparison very easily. What about the comparison in all these three various stages? And this was important there. Very good. Everybody have a response? Great. I don't know why every time you will say yes. Either I'm teaching so much good, yeah, you are so much intelligent. What is the truth? I don't know. So because of stability of uranium-233 was derived from thorium. I'll come into the comparison, don't worry. Okay, stability of uranium-233 or not, that discussion I will do. Wait, Shrikant. Okay. So I think so the second reason is the main reason. Students are very good. They literally have a lot of, proper have IQs. Okay. Recently there was news that Iran is the enriching uranium up to 60%. So does it mean that they are going to it in the first stage? See. Sweekriti, I'll give you your answer, bacha. Actually, first time when Iran declared I have an atom bomb, their uranium was hardly 30%, 20% enriched. More enriched uranium, more effective atom bomb. Iran declared now I can enrich. When the Iran first declared I have an atom bomb, then it was understood that that is not more better atom bomb because that enrichment of uranium was very less. Now Iran declared I have a 60%. So it means now the Iran atom bomb is improved. Will improved. And when Iran declared, of course, sometime now I have a 90% enriched, then much more high. I hope you got your answer. Sweekriti, I told you. Enrichment level matter. More enrichment, more destruction of atom bomb. I still remember 10 years back, 8 years back, when the Iran has done the first nuclear test, Iran declared I have atom bomb. But that atom bomb was not much more powerful because the enrichment level was hardly 20%. So here Iran is showing, no, don't worry. Today I have a 60%. My atom bomb is better. I hope this is the logic behind it. You people never know because 8 years back, I have taken a classes, so I remember. So what happened in the past 18, 20 years, I have seen. The weightage of science tech increases from 11 onwards, from last 10 years. Acha, teaching is good, sir. But you people are not good. Relation in yellow in under which stage? Actually, why you are asking yellow? But I'll tell you one thing. Those uranium we are going to take from the other countries, this is called as a yellow cake. Because you mentioned the name Mehak as a yellow na, so I understood what you are using the yellow. I think you are asking something regarding the yellow cake. You know, what is the yellow cake? But see guys, it is not a demand of UPSC. Okay, this type of things are not required for UPSC, but Mehak even asked something about yellow, so I suddenly recall. Those uranium we are going to take from the other countries, it is called as a yellow cake. Yellow cake. Cake, you know, cake. Yellow cake. This is the term used for the importing uranium, yellow cake. Acha, everybody is. Okay, Mehak, fine. Acha, I'm teaching good. It is not I am teaching good, okay. You are also good. And everything is not happen only from single side. I'm not only teaching good, you are also good. And definitely guys, if a quality teacher and quality student meet at the same place, so one at a time I think it is enough. I think it's not like that you people only praise me. Yeah, I should also praise to you people guys, because you have given me the response also. Okay, so mutually happen guys. Only one sided not happen. Teacher, how much it is good. Okay, does not matter if a student quality is not good. But yes, if teachers and quality students both, definitely that is the reason. I know very well guys that always have a value of Dronacharya. Why it was? Always value of Kalam Sahab type of teachers. Why have a values? I know very well. But parallelly, Kalam was also one of the students. So similarly, the Kalam type of students also in my class are not, it also matters a lot. So the selection is depend on mutual guys, teacher and students both. Okay, fine. Now, one thing more guys. Some discussion is required. So whenever I'll use the thorium, so I hope you remember in the background have uranium-233. Actually guys, some discussion is required here. That is called reprocessing plant. You just see what I am doing. The discussion is reprocessing plant. Discussion is reprocessing plant. Discussion is reprocessing plant. So discussion is reprocessing plant. Reprocessing plant. What is the importance of reprocessing plant? Actually guys, when this plutonium-240 you people burn, okay, when uranium-92 you people burn, nuclear waste generate. Here also a nuclear waste generates. Even when uranium-233 you people burn for electricity generation, again nuclear waste generates. Because nuclear fission generate nuclear waste. I hope you remember during discussion of fission and fusion, I told you fusion not generate nuclear waste, but fission generate nuclear waste. So of course here nuclear waste generates. Nuclear waste generate. And see this nuclear waste, we cannot dump anywhere directly. It is very dangerous. This is the reason to recycle the nuclear waste in 1964. India has set up the first reprocessing plant in Trombay. Trombay is what? It is in Maharashtra. Trombay is what? It is in Maharashtra. And with that guys, India became the 4th country in the world to achieve this. To India achieve it, the 4th countries in the world, India became here to have a what? To set up a reprocessing plant in the world. So the 4th ranking. But today I'll tell you guys, some more areas, some more places have also reprocessing plants. And here what we are doing? We are doing the recycling of nuclear waste. So here the nuclear waste are not dangerous. And then we are going to do somewhere the dumping of it. But after recycling it. Okay, some more places like Tarapur, it is also in Maharashtra, have also reprocessing plant. Even Kalpakkam, Tamil Nadu, have also, have also what? Reprocessing plant. So Kalpakkam, Tamil Nadu have a reprocessing plant. So many places have a reprocessing plant. I hope you understood about the importance of a reprocessing plant, equally important. For the different reactors have a wastage, and these all the wastage will go here for its recycling. And I hope you know very well guys, Tarapur and Kalpakkam have also nuclear reactor where we are generating electricity. And same places have a nuclear waste, we people will recycle to the reprocessing plants. Okay, reprocessing plant. So now the fuel part and reprocessing plant, two portion I have discussed. Now you come into the second part, that is called moderator. Now you come into the second part, that is called moderator. Okay, second part, that is called as moderator. Second part, you come as a moderator. Okay, moderator. Moderator. So give an exciting moderator. 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 What is the purpose of moderator? Okay, Partha, I am telling you, wait. Moderator, coolant, fuel, after it, control rods, reactor, many discussion I'll do, wait. So come here into the moderator. What is the use of moderator? You just try to understand first. Suppose I'm a nuclear scientist. I involve into the Tarapur nuclear power plant. You know the first nuclear power plant was set up in India, it is in Tarapur. It was in Tarapur, Maharashtra. Okay, fine. So I'm telling you guys, those moderator is required. Yeah, I'm telling you, I'm a nuclear scientist. I'm going to start a nuclear fission reaction. Okay, for nuclear fission reaction, those I'm going to start. Okay, result, electricity generations. Here a lot of things are required parallelly to start this reaction and to control this reaction, to manage this reaction safely. Here moderator play a role. Where we people perform the nuclear fission reaction, it is a reactor. Reactor discussion I will do in the last. Reactor, I can tell you, it is a kind of nuclear furnace. Reactor is a kind of nuclear furnace. So reactor is a kind of nuclear furnace. Bhatti. Where we put the uranium, and in this chamber of reactor, those reaction is going to perform, it is safe. If I burst the uranium here in your room, guys, and the roadside, guys, the people will come under the effect of heat and radiations. It will be dangerous. So within the reactor, the nuclear fission reaction we perform under a very controlled manner. Okay, so within the reactor, I'm going to start a nuclear fission reaction as a nuclear scientist. So how to start? Moderator is also required here in this case. So what will come here? See guys, what is the role of moderator? Come. Actually, in the beginning, as a nuclear scientist, I have given a neutron, send a neutron for this reaction to the uranium. So uranium with a slow speed of neutron. Actually, it's a property of uranium 235. That uranium 235 burned with a slow speed of neutron. Okay, but what happened? So this neutron is finished. When this neutron break the uranium, neutron lost. But in the result of 3 neutrons generate, and those neutrons generate after this breakdown of uranium, neutron those generate, here the speed of neutron becomes so much fast. So one uranium already broken, energy generation happened. This neutron finished after breakdown of uranium. Next time this neutron will go for the breakdown of next uranium, but uranium will not break. Reason, it is the nature of uranium, it's a nature of chemical reaction of uranium, that for the breakdown of uranium, speed of neutron should be slow, but here speed of neutron is very fast. So this is the reason, guys, to make this reaction continue. Okay, what is important? The neutron speed should be slowed down. Here moderator is used. Here we are using moderator. So what moderator is doing? Moderator further slow down the speed of neutron. Again uranium break. Again neutron generate with the fastest speed. Don't worry, inside the reactor have a moderator. This moderator will again slow down the neutron speed. Again uranium break. So this reaction continue. Inside the reactor, heat generation continue. I want everyone answer understood. So Partha I described. So what is the role of moderator? I describe you. I want everyone understood answer. And then I'll dictate. Okay, right? Right. Very good. Everybody won. Good. Great. It was a question in 2011. It was a question paper in 2011. 2011. Great. Everybody understood, right? Uranium break with the slow speed of neutron, right? Uranium break with the slow speed of neutron. 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 But speed of emitted neutron is so fast. But speed of emitted neutron is so fast. But speed of emitted, EMITTED, but speed of emitted neutron, this neutron emitted. But speed of emitted neutron is so fast. Okay, right? So moderator used to slow down the speed of neutron for further reaction, right? So moderator used to slow down the speed of neutron. So moderator used to slow down the speed of neutron, for further reaction. To slow down the speed of neutron for further reaction. Okay, to slow down the speed of neutron for further reaction. Okay. See guys, heavy water and graphites are the good moderator, right? Heavy water and graphites are the good moderator. Heavy water and graphite are the good moderator. Even heavy water we can also use as a coolant, but you write heavy water and graphite are the good moderator. So heavy water and graphite are the good moderator. So heavy water and graphite are the best moderator. Now come next, that is called coolant. Coolant. See guys, how much the balance of a reaction is required to make a reaction hold control and all. Lot of things are required here. Okay, lot of things are required here. You just come. Coolant. What is the use of coolant? You know guys, every chemical reaction perform at some pressure and temperature, right? Every chemical reaction perform at some pressure and temperature. Every chemical reaction perform at some pressure and temperature. Write down. Every chemical reaction perform at some pressure and temperature. Every chemical reaction perform at some pressure and temperature. One thing more guys, today there is no discussion of first stage, second stage and third stage. But whenever a teacher will start to discuss with you nuclear energy, the teacher start from first stage, second stage and third stage. The reason is actually what guys, today we people have totally changed a lot of things because new technology innovation happen. Okay, new isotopes, new moderators, new coolants. But whatever the Bhabha told you guys, every time when the nuclear energy program starts, so definitely in the honor of Bhabha, we will start 3-stage nuclear energy development program. Okay, but in the present scenario, what is going on? These all are going on. So you follow, these all are going on. Okay, these all are going on. Now come. So I told you guys every chemical reaction perform at some pressure and temperature. So definitely this is also a kind of chemical reactions. This is also a kind of chemical reaction those we are going to perform, definitely. So this is also a kind of chemical reactions. You know what we are doing in this chemical reactions. Actually this chemical reaction is an exothermic reactions. Heat generates a lot guys inside the reactor guys. And due to more heat guys, there is a possibility this nuclear fission reaction, the entire nuclear fission reaction can stop. This entire nuclear fission reaction can stop. This entire nuclear fission reaction can stop. And there is a difficulty. This reaction stop, heat formation stop. So to maintain a proper temperature inside the reactor, when the heat is going to increase, the heat will cool down, further the breakdown of uranium continue. It's very simple guys. inside your body, also kind of chemical reactions. Your digestive system, your respiratory system, your circulatory system, these all are what? Your metabolic system. Your metabolic system is also the kind of what? Also is also working under what? Under pressure and temperature. So you people are also a chemical compound. Do you know? If loin eat up a protein. Inside your body, those digestion, circulation mechanism is going to be happen. It is a part of what? It is a part of metabolic activities. And these all the activities, I can tell you, these all are the chemical reactions. Digestion is a chemical reaction. Circulation, breakdown of food for energy generation is a chemical reaction. And every chemical reaction perform inside your body at also some pressure and temperature. Pressure, your normal BP 80 to 120 mm mercury, and temperature is I hope you know very well, 98.6 degree Fahrenheit or 37 degrees Celsius. So 98.6 degree Fahrenheit or 37 degrees Celsius. Okay, so you tell me guys, if your body fever temperature increases, so what about the chemical reaction inside your body? Sir, all disturbs, sir. Even the food digestion leaves, sir. Even the food test not happen. So as like inside your body have read up proper temperature and pressure, that's why your body metabolism, your chemical reaction perform. Similarly here in this case, again have read up proper pressure and temperature. But the negative of this is what? This reaction is exothermic, even inside our vehicles. Cars and all, we are using the coolants or not. And that is the reason 1,000 kilometer non-stop you are moving because of synthetic coolants. Your engine is not going to heat up, guys. If more heat up your engine, guys, so burning efficiency of fuel is stop, your vehicle is stop. Earlier I have remember, guys, we people was not using the synthetic coolants. Normal water we people use there. When the engine heat up in the summers, guys, what we people do? Just wait for some duration of time. We people carry the water in the gallon and throw on engine. Just cool down, please. Just cool down, please. When the vehicle cool down, now you just give yourself, you know what happened? Your vehicle on, you start to move. The same thing here also. Same thing here also. Okay, everyone? Right. Nuclear fission reaction is an exothermic reaction, right? Coolant. I hope everybody clear. Just give me yes, because one you already have seen. Ab you give me yes. Neither I will be confused. It is a one was previous one wala, it's a new one wala. So yes, sir. So sometime your answer will be yes, sometime your answer will be one, sometime your answer will be understood in this way. So here you people will connect with me, and I want that class, entire classes, you people should connect with me. Okay, right. Nuclear fission reaction is an exothermic reaction, right? Nuclear fission reaction is an exothermic reaction. Nuclear fission reaction is an exothermic reaction. Nuclear fission reaction is an exothermic reaction. So heat generates. So heat generates. So heat generates. Nuclear fission reaction is an exothermic reaction. So heat generates. So heat generates. Coolant used to maintain proper temperature inside a reactor. Write down. Coolant used to maintain proper temperature inside a reactor. So coolant used to maintain proper temperature inside a reactor. Right. Coolant used to maintain proper temperature inside a reactor. Okay, inside the reactor. Okay, inside the reactor. Fine. Now come next. That is the control rod, right? Control rod. This is the important one. I'm expecting this question in your coming year. Control rod. Control rod. Control rod. Either you call control rod or you can call as a absorbent rod. So control rod or absorbent rod. Come. Control rod or absorbent rod. So control rod or absorbent rod. Control rod or absorbent. Write it. Write it. Actually, you know, this rod is very, very important. Two terms I want to clarify. One, first, control and uncontrolled reactions. Controlled reaction and uncontrolled reactions. What is the meaning of controlled reactions? That whatever the energy generation you want, up to that level energy generation is going to happen. Reason, reaction is under control. Uncontrolled reaction means massive heat or energy is going to generate without your control, guys. Uncontrolled meaning. And here in this case, it become destructive. Even in the case of atom bomb, nuclear fission reaction, we try to make it uncontrolled. That's why massive heat or energy generate and massive people lost. But in the case of electricity generation, nuclear fission reaction should be under control. So control reaction is required in the case of electricity generation. I think I differentiate this chemical reaction nature. In various cases, different type of nature required. The reaction should be under control if your purpose is electricity. If this electricity reaction inside the reactor become uncontrolled, so a disaster is possible. Those I hope you people know very well, Chernobyl disaster, I hope you people know very well, in Ukraine. Because by mistake, those reaction of nuclear fission perform inside the reactor, it becomes uncontrolled. And because of uncontrolled, what happened? Infinite heat or energy started to generate, massive, out of control. And because of it, what happened? Casualty. 21 or 23 people were working in that time within the reactor, everyone die. So, nuclear fission reaction should be under control. This logic I hope everybody clear. Nuclear fission reaction should be under control. Fine, now come here. So now question is, how we can make control this whole nuclear fission reaction if our purpose is electricity generation? You try to understand here. Okay, you try to understand here. See guys, one neutron, see here, come here. One neutron break one particle of uranium. Try to understand. Suppose this is a reactor. Suppose this is a nuclear reactor where this reaction is going to perform under control manner. If the reaction become uncontrolled heat or energy generated, this reactor can burst. This reaction can burst. Now listen. Okay, this neutron is going to break down of uranium. Okay, this neutron is going to do breakdown of uranium. Now what will come next? When the single neutron is going to break a uranium, 3 neutrons generate and heat or energy. 3 neutrons generate and heat or energy. So 3 neutrons generate plus heat or energy. So this heat or energy, I am telling you, one time of heat or energy, because only one particle of uranium break with the 1 neutron. But next time how many neutron is there? 3 neutron is there. So when 3 neutron will come, this neutron finished because it already breaked. When this neutron will come, so it will break how much number of uranium? 3. 1 uranium, 1 uranium, 1 uranium. 1 break, 1 neutron, another uranium break by another neutron, another uranium break by another neutron. Because total how many neutron is there? 3 neutron. 1 neutron break, 3 neutron generate. 1 neutron break, 3 neutron generate. 1 neutron break, 1 uranium, 3 neutron generate. 1 time energy, 1 time energy, 1 time energy. Total 3 times of energy generate. So inside the reactor, guys, first time only one time of energy generate. This time 3 neutron break. So of course 3 times of energy generate. More load this reactor will be here right now. Next time how many neutron will come? 9 neutron will come and do the breakdown of 9 uranium. So if 9 uranium break with the 9 neutron, total how many neutron generate? 27 neutron. And how many types of energy? 9 times of energy. 9 times of energy. So 9 times of energy. And next time how much? 27 neutron go back down of 27 uranium. It become as a chain reaction. I hope this term you read it into chemistry, guys. Chain reactions. 1 time 1 time energy. Second time 3 time of energy. Third time 9 time of energy. 4 time 27 types of energy. Now finally what happened? This whole reactor can burst. This whole reactor can burst if the reaction become out of control. Its reaction is not under control. I hope you understood why this Control rod is very important. And this control rod, those we are using into the nuclear reactor, they are made up of cadmium and boron. They are made up of cadmium and boron. They are made up of cadmium and boron. And I'm expecting this question for your paper. I want everyone answer as one, and now you write. To control a nuclear fission reaction, yeah, directly you write boron and cadmium used. Boron and cadmium used. Boron and cadmium used. Great guys, nice. Boron and cadmium used as a control rod, in nuclear fission reaction. Boron and cadmium used as a control rod in nuclear fission reaction. Control rod in nuclear fission reaction. In nuclear fission reaction. Control rod in a nuclear fission reaction. Okay, right? Control rod absorb extra neutron. Control rod absorb extra neutron. Control rod absorb extra neutron during nuclear fission reaction. Control rod absorb extra neutron during nuclear fission reaction and try to control whole nuclear fission reaction for power generation. In a controlled manner. Power generation, in a controlled manner. Power generation in a controlled manner. Okay, power generation in a controlled manner. Everybody clear? Okay, power generation in a controlled manner. Okay. Now come into the discussion of reactor. One line only you can write. It is a nuclear furnace. You already have seen. Reactor is what? It is a nuclear furnace. It is what? It is a nuclear furnace. So reactor is what? It is the nuclear furnace, right? It is a nuclear furnace. So reactor is what? It is the nuclear furnace. Okay, it is a nuclear furnace. Actually, there are different types of reactors. Now come directly, types of reactors. Types of reactor. The one you come that is called PHWR. And second you write that is called breeder reactor. And second you write this is called breeder reactor. So right, one is a PHWR, write down its full form, pressurized heavy water reactor, right? Pressurized heavy water reactor, right? Pressurized heavy water reactor. Pressurized heavy water reactor, PHWR, this is pressurized heavy water reactor. Pressurized heavy water reactor. What are the pressurized heavy water reactor? Very simple guys. Okay, already here answer is given. A reactor where heavy water is used and generally high pressure is maintained. A reactor where heavy water is used and high pressure is maintained. So no need to write anything. Within the nomenclature already all information is written there. So a reactor where heavy water is used and high pressure is required. Pressurized heavy water reactor. Pressurized heavy water reactor. Okay, pressurized heavy water reactor. I hope you understood. Next one guys. What is a breeder reactor? What is a breeder reactor? I'm going to praise myself in the reference of breeder reactor, so it will be easy to understand, but I'm going to praise myself. Don't mind, guys. Okay, first day when I have shown you the question papers. First day when I have shown you question papers. How many questions you people were able to solve? When first day I have shown you question paper, how many questions you people were able to solve? In science, overall in the 15 questions. So I think 1. Okay, 2. Okay, 0. Because 1, 2 question answer you wrong. Yeah, okay, fine. Some extraordinary and brilliant student. Those without preparation or overconfident, without studying. Maybe 10 plus. Overconfidence people everywhere. Without having a knowledge, without have done the hard work and exercise, people are confident. Great confidence. But now because of me, what you think so? So now because of you, sir, I think so that now I'm able to solve some more number of questions. Those earlier we stand, now today because of some classes, only few classes happen, sir, only first chapter is running. Still many chapters left. Okay, but yes, at least in few days, you have given me some confidence. And I feel that you told me that 10 plus question I'm able to solve, so maybe it will be possible. Yes, to prove it, you just must have to listen complete lessons. I just have a 3-4 lectures. I think that's 4 lecture only. I'll take around 25 lectures, 22-25 lectures. So you people believe something. So this belief or confidence, those you got, it is because of me. So I am working in your life as a breeder, where your efficiency enhanced. So me myself is called as a breeder reactor. So what is a breeder reactor? A reactor where efficiency of will enhance for power generation. So I'm that reactor. Yeah, inside is that institution where you people are coming, your performance, accuracy, reliability is going to enhance. So this inside I can tell you it's working as a breeder in your life. I hope I described. Again here you will give me yes answer. Here you will give me a yes answer. So right, breeder reactor. Those reactor where efficiency of will enhance for power generation. Those reactor where efficiency of will enhance for power generation. So those reactor where efficiency of will enhance for power generation. So those reactor, great guys, great. Everybody, yes. Okay, nice example, Sunny, okay, but I praised myself. The reason it was a very simplest way to define breeder reactor through the help of my example. That's why I use it. Don't take it other way, guys. Okay, because I know still I have learned a lot of things. In the last 20 years, I have learned. And I, of course, in the coming next 20, 30 years, I will again learn more. When your son and daughter will come in my class after 20, 30 years. So in that time, my level will be something better from this time. Okay, but still I will be in the learning process. Because teacher is those guys where the learning process never stop. Okay, so my learning process will never stop. After 30 years, your son and daughter will come in my class. You people will proudly say, hey Ravi sir, you are, oh great, inside you got it. Oh, Ravi sir, he also taught me. The book, I read it, guys. Oh, go and follow him blindly. Okay, during my time, he has 18, 20 years experienced. Okay, and then after 30 years, oh my God, 50 years plus. Okay, great. So I love to teach your kids also. Okay. Okay, fine. Come ground. First you crack, then you will have a kids. Okay. So yes, breeder reactor. The efficiency of will enhance for power generation. It's a breeder reactor. But one thing I'll tell you, a quality reactors will cheaply available. Very simple. I can be available everywhere. No, I also have some my values. Just like after crack this UPSC, you will have your own values. Of course, for your value purposes, you are going to crack UPSC. So how I can be available everywhere? Of course, many factors works to join institute by any teacher, not even the single factor. Okay, many factors work to join institution. So I hope you understood, guys. So definitely these type of reactors are also costly. So money also matter, guys. So these reactors have a drawback. These reactors are costly. So what about a beta reactor? These reactors are costly. This is a drawback of these reactors. Don't tell me I'm costly, teacher. No, I'm very cheap. Bolna bhi there is different, very different words. Okay, so I just love to connect with the insight because I got that multiple number of students are here. That's why I said yes. Because whenever I'll take a 3 hours classes, I can connect 1,000 of the peoples. So how I can miss this opportunity? Because 1,000 peoples are what? My asset. Money is not asset. 1,000 people are my asset. More than 1,000 people. Because through the help of 1,000 people, this 1,000 people are connecting with the multiple 1,000 peoples. So I can connect with the lakhs of the peoples. So I hope you understood how much I am cunning here to connect with you guys. Money does not matter. Money though one time you already finished. But those assets I am going to generate here to connect 1,000 and 1,000 peoples. And these 1,000 people connecting with the multiple 1,000 of friends. Those are preparing UPSC. So now my name, whenever I die, at least many people will know one of the quality teacher is going to die. Don't worry, I will not die. Don't worry. But I'm telling you the reality. Okay, yes, the breeder reactor you clear. Now come directly. Different types of breeder reactor. The one you come is a TBR. Second you come as a FBR. The first you come that is TBR and second you come as a FBR. What is TBR? TBR is a thermal breeder reactor. TBR is what? This is a thermal breeder reactor. BREEDER. This is a thermal breeder reactor. And what is it? This is a fast breeder reactor. This is fast breeder reactor. So thermal breeder reactor and fast breeder reactor. Thermal breeder reactor and fast breeder reactor. So reactor, I hope everyone know. Reactor is a furnace. Breeding technology you also know very well. And thermal means a temperature should be high. So thermal breeder reactor you understood. It's a reactor where the breeding technology is used and generally we maintain high temperature. So thermal breeder reactor. Generally we maintain high temperature thermal breeder reactor. Okay, this is the thermal breeder reactor. What about a fast breeder reactor? Actually in some cases, some isotopes of fuels, they break with the slow speed of neutron. They break with the slow speed of neutron. And in some cases, they break with the fast speed of neutron. Some such radioactive elements, nuclear fuels, those burn with the fast speed of neutron inside a reactor. That reactor is called as a fast breeder reactor. So this is the reason here in this case, generally we people not use moderators. If you people will use the moderator, speed of neutron slow down. I told you guys here you people will confuse. So first of all I will clarify, uranium-235 break with the slow speed of neutron. So that is the reason in the first stage we must have to use a moderator. But in second stage where you people have seen plutonium break with the slow speed, fast speed of neutron. That's why in the second stage you people have mentioned rarely moderator used. I hope you will never confused. Even for the breakdown of uranium-233, still have a need of what? Some faster speed of neutron. Yeah, overall it's important, fast breeder reactor. FBR was the question in the last year in your mains paper 2019. India has a future with the fast breeder reactor. Why so? The reason is guys that our thorium derived uranium-233 is the best place for its breakdown. Okay, so fast breeder reactor have a future with the India, but problem is TD. But the problem is costly. These are the two reasons with the fast breeder reactor. What about the limitation with the fast breeder reactor? The limitation with the fast breeder reactor, what? Limitation with the fast breeder reactor, technology demonstration and costly. TD is a technology demonstration. Many places I will use the term TD, technology demonstration. And it was a mains question paper 2019, technology demonstration. How fast breeder reactor is important for India? The reason you people know very well, because this is the reactor where India will burn thorium fuel. And thorium highly abundantly present in India, everybody know. So of course, India have a future with the fast breeder reactor. But what about the limitations? Technology demonstration. What about the limitations? This type of reactors are costly. What is the meaning of technology demonstration? Listen guys, technology demonstration means at a small level, this research becomes successful and even it is started. But further have a need of some more improvement in this reactor. So technology demonstration means at a small level, this reactor has been developed, but further have a need of lot of improvement, and that is the reason this reactor have a lot of future. So your question is, so sir, it means India has started the use of thorium? Yes. India has started the use of thorium. But what about the limitations? Limitation is those reactor where we people burn the thorium derived uranium-233 is generally costly and still have a need of some more improvements. I want one answer from everyone. 2019 mains. Even in your mains paper also UPSC asks creative questions. I'm expecting one from everyone. And here you people will go into the comparison between uranium and thorium. Some more information I'll tell you. You come comparison between uranium and thorium. UPSC prelims 2012. Very good, very good. You just give me one, I will give you more and more and more. Great, great. Double one. Who is this? Manjushri? No, somebody is double one. Oh my God. Somebody is double one. Manjushri, double one. Oh, good. See, right? Comparison between uranium and thorium. 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 So uranium versus thorium. But you people know very well, uranium is generally I am discussing uranium-235 and thorium is generally I am discussing uranium-233. I think you people very clear. Uranium-235 and uranium-233. So uranium is what? Uranium isotope 235. Thorium is what? Uranium isotope 233. So there is a comparison between uranium-235, it's a 235 and it's a 233. So comparison of 235 and 233. Okay, what will come here? Listen guys, in this case. So comparison is here. My question is guys, first questions. Which one is more abundantly present in the nature? Which one is more abundantly present in the nature? Uranium-235 or uranium-233? Means this uranium or this one wala thorium wala uranium. Which one is more abundantly present in the nature? Now question answer session. Which one is more abundantly present in the nature? Which one is more abundantly present in the nature? You guys are wrong. Thorium is more abundantly present in the nature, right? More abundantly present in the nature. It is more abundantly present in the nature. Yes, thorium is more than uranium. Somebody is right, thorium. Okay, but you must be clear guys, thorium based uranium-233, yeah, thorium is more abundantly present in the nature. So nature wise, thorium is more. Thorium is more, first. Second one guys, second questions. So it's comparatively less. Second questions. Second questions. Second question, your answer will be 1 and this will be your answer 2. Means uranium, because U-235, U-33 you people have mentioned. So I did not identify. Your answer will be either 1 means this one correct and 2 means this one correct. Which one is more efficient for power generation? Which one is more efficient for power generation? Tell me, which one is more efficient for power generation? So which one is more efficient for power generation? If uranium-235 you will use, in that case have a more power generation. Yeah, uranium-233 you will use, in this case have a more power generation. See, this is more efficient also for power generation. This is more efficient also for power generation. In the both two cases, what you got? You got thorium is better. Wait. One more points. You know, when uranium-235 burn, when uranium-233 burn, when uranium-235 burn, uranium-233 burn. Okay, when uranium-235 burn, uranium-233 burn. My question is, in both two cases have a nuclear waste generations. Of course, nuclear waste generates. It's a nuclear fission reactions, both two. In which case have a more nuclear waste? Yeah, in which case have a less nuclear waste? Here answer will be uranium-235 or uranium-233. Which one produces less amount of nuclear waste? Which one produces less amount of nuclear waste? Which one produces less amount of nuclear waste? Uranium-235 or uranium-233? Uranium-235 or uranium-233? Oh, great. Here everybody right, uranium-233. Here everybody right, it produces the less amount of nuclear waste. In this comparison, less amount of nuclear waste. So overall what you got? Overall you got what? Thorium is better than uranium, right? So thorium is better than uranium, right? So thorium is better than uranium, right? So thorium is better than uranium, right? Have you people understood what about the future of India with thorium? I hope you people understood what about the future of India with thorium. Okay, fine. So thorium is better. And now you understood what about the limitation with the use of thorium? TD, reactors, costly, two factors. But one thing I'll tell you, definitely you people will crazy to know about fast breeder reactor and thorium reactions. Sir, where India has started the use of thorium for power generation? So write note. Write a note. A prototype fast breeder reactor. A prototype fast breeder reactor, right? A prototype fast breeder reactor. A prototype fast breeder reactor. A prototype fast breeder reactor. Set up and working at Indira Gandhi Center for Nuclear Research. Right, Indira Gandhi Center for Nuclear Research. Indira Gandhi Center for Nuclear Research. Kalpakkam, Tamil Nadu. With Indira Gandhi Center for Nuclear Research, Kalpakkam, Tamil Nadu. With 500 megawatt power generations. With 500 megawatt power generations. So it means with 500 megawatt power generation, India has started the use of fast breeder reactor. Yes, but one term I use there with the fast breeder reactor, prototype. Prototype terms, if anywhere it will come, guys, you remember it's experimental type. If prototype fast breeder reactor come anywhere, it means what? It's a experimental type. So if anywhere terms come as a prototype fast breeder reactor, it means it is an experimental type. Okay, it is an experimental type. Okay, it is an experimental type. Okay, experimental type is here. Fine. Some questions I can see here. So any reasons why thorium is more efficient? But atomic structure, rate of chemical reactions, many factors work. But that factor based discussion I'll not do here. It will be a part of experiment and research. You just come in the conclusions. We Indians are doing the engineering, but we Indian have a theoretical knowledge. You see, many of the engineers are listening me. But you tell me how much the practical you got it. The reason research and development facility is not available in India, so you engineers are the theoretical knowledge, not have a practical knowledge. So don't go on practical also. Even in UPSC it is not required. Even engineering subject students have not done the practical, how here you can do. But here you just remember it's experimental part, those happen. Even in my subject, at least you people ask me, sir, how it is. Why? But in history method, you people never ask, sir, whenever you come in the class, today you will discuss Babar, you come with the Babar in the class. Neither I will not understand. Ravi sir when discuss the fuel cell, so Ravi sir make on the board fuel cell. If you are discussing the fuel cell, Babar, so you come with the Babar. When you are going to start the non-cooperative movement or anything, so sir, you come with the Mahatma Gandhi in the class. Today these people are no more. So don't try to do the practical in the class. Try to understand theoretical in the class only. Theory part. Okay, fine. So reason is just indirectly I was giving you answer. It's experimental part, nothing more. So sir, then why India buy uranium from the other country? Again I am telling you, TD. Again I am telling you, technology was not developed. India is starting. In the coming future, definitely we will enhance the use of thorium. But this time we are lacking. Shrikant. Sir, what do we mean by reaching the criticality of a particular reactor? I'm not getting Pratik your questions. Okay, fine. So now here I'll give you about the, you know guys, one thing more. Those reactors are working in India. Those reactors are working in India. Those reactors are working in India. Generally 7 reactors. Generally 7 reactors are working in India. The first one I told you it was in Tarapur. I have given the name of reactors. Okay, I mentioned the name of reactors in your book. Okay, it's a factual data, but according to the present demand, okay, UPSC is not asking about the reactors, locations and all. But in the last pattern till 2010, this type of questions was very common in your paper. 7 reactors, those are working in India. That's the page number 4.11 I have given it. At page number 4.11 I mention it. Table number 4.3 and table number 4.4. Table number 4.3, it's a working reactor. Working reactor. Here the 7 name you will get it. And table number 4.4, it is belongs from chapter number 4, page number 4.11. Future reactor, the list of future reactor, the list of future reactors, the list of future reactors. Okay, list of future reactors. Working reactors, with the help of it, the 7 reactor, those I'm telling you around, those are already working here. Where the first one was a Tarapur, I'm repeating many times. With the help of it, guys, of 7 reactors, 3 to 4% of power generation in India by nuclear energy. 3 to 4% of power generation in India by nuclear energy. These reactors you can see like Tarapur in Maharashtra, Kaiga is in Karnataka, Narora, it is in Uttar Pradesh, Bulandshahr. Okay, Rawat Bhata, this is in Rajasthan. Kalpakkam, this is in Tamil Nadu. Next one is Kakrapar, Gujarat. Kakrapar, this is in Gujarat. Kakrapar, Gujarat. And one more is a Kudankulam. Kudankulam, Tamil Nadu. So these are the 7 reactors. Okay, these are the 7 reactors. With the help of the 7 reactors, 3 to 4% of nuclear energy generation we are doing in India. You know guys, world average if you will go, if you people will go the world average, just like world average the power generation by coal, 60% of worldwide power generation by coal. What about the world average contribution of nuclear energy for power generation? So world average nuclear power based energy generation is a 14%. So world average is a 14%. So nuclear power generation worldwide, contribution of nuclear power worldwide, 14% of whole electricity. 14% of whole electricity. 14% of whole electricity in the worldwide by nuclear energy. So 14% of whole electricity in the worldwide by nuclear energy. So 14% of whole electricity worldwide, it is by nuclear energy. So 14% it is by nuclear energy. Okay everyone, next point. By nuclear energy. And here India is lacking guys, very less from the world average. Very less from the world average. I have one more question guys. Which country have a maximum energy generation? Overall in the power generation, maximum power generation by nuclear energy. Can you tell me guys? I just wanted to see your GK. I just wanted to check which country have a maximum power generation by nuclear energy. I think so it is a GK questions. UPSC has not a demand of it, but I just to check guys, what about your GK? Japan, China, Russia, China. Yes, I started to get a correct answer. Someone is name as a student. Better you write your name guys, okay. It's a France. France is the leading country in the world. Total power generation, whatever in the France is going to be happen, approx 70% by nuclear energy alone. By nuclear energy. Approx 70% power generation by nuclear energy. So approx 70% power generation is nuclear energy. France is the correct fact guys. So overall those electricity generation happen in the France. Here 70% of electricity in the France is by nuclear energy. So 70% of electricity in the France only by nuclear energy, you people remember. Okay, it is by nuclear energy. It is by nuclear energy. Listen, by nuclear energy. Some countries, those are dominating in the use of nuclear energy. Most of the European Union and Japan, right? Some more information, right? Some factual data. Most of the European Union countries. So most of the European Union countries and Japan. In most of the European Union countries and Japan. In most of the European Union countries and Japan. So in most of the European Union countries and Japan, 30% power generation. 30% power generation. 30% power generation by nuclear energy. 30% power generation by nuclear energy. So 30% power generation by nuclear energy. So 30% power generation by nuclear energy. Okay, and India is how much? It's 3 to 4%. 3 to 4%. Now write one more statement in the reference of nuclear energy. Nuclear vision of India, right? Nuclear vision of India. Come, nuclear vision of India. Nuclear vision of India. Nuclear vision of India, right? Nuclear vision of India. Nuclear vision of India. Okay, so nuclear vision of India. What will come in the nuclear vision of India? See guys, one vision timing is over, but I'll start from that. NV 2020. This time is over guys. Because today the timing is, today's day is what? 17 June. 17th June 2021. I'm taking your classes. Here 2020 is past. Nuclear Vision 2020, its target was 20,000 megawatt power generations. 20,000 megawatt power generation will be by nuclear energy. And India made it successful, don't worry. India made it successful, 20,000 megawatt power generation India by 2020. Nuclear energy, it achieved. Don't worry, it achieved. This is already achieved. Okay, this is already achieved. The second vision of nuclear India, Nuclear Vision 2032. 63,000 megawatt power generation India by nuclear energy. The second target. Let us see. I hope so. India will make history. I hope India will make a history. And for that purposes, the future reactor India is planning. And you know, guys, many places as a future reactor India is planning. That table number 4.4, I told you it is written there. Like Kudankulam, Tamil Nadu, Jaitapur, Maharashtra, Mithivirdi, Gujarat, Kowada, Andhra Pradesh, Haripur, West Bengal, Kumharia, Haryana, Bargi Chutka, Madhya Pradesh, Markandi, Odisha, Bhimpur, Madhya Pradesh, Madras, Tamil Nadu, and Mahi, Baswada, Rajasthan. These are few more new locations even identified. The government has decided to set up the reactors. Neither how our nuclear vision in the coming future will achieved. And one thing more, guys, I'll tell you here, to set up a nuclear reactor, it's not a one-day task, not a one-year task, not a few years task. It takes many years. If you want to set up a reactor, at least minimum 10 to 15 years is required. A lot of safety mechanism, we also use it. A lot of safety mechanism, we people also use it. So 10 to 15 years is required. At least minimum 10 to 15 years is required. 10 to 15 years is required. Okay, so those reactors we are planning today, it will give a result after many years. Maybe during your son and daughters and all. Okay, they will enjoy that nuclear energy based power generations. Next one, next one, next one. The Nuclear Vision 2050. Nuclear Vision 2050. Nuclear Vision 2050. You know, this time those nuclear energy based power generation in India we are doing, it's around 3 to 4%. It's around 3 to 4%. This 3 to 4% by 2050, it will reach around 25% of whole electricity. 25% of whole electricity. 25% of whole electricity. So the target of 2050, 25% of whole electricity. 25% of whole electricity. And here in this whole electricity, I'll discuss its overall nuclear vision of India. If I'll tell you about thorium vision of India, because India is visionary with the thorium. Here I will clarify about thorium vision of India. Here I will clarify thorium vision of India. Here I will clarify about thorium vision of India. You know what about the thorium vision of India? Thorium vision is what you just see. In this 25%, in this 25%, in this 25%, in this 25%, okay, 70% of power generation. Those we will try to generate by 2050. Here in this 25%, 70% by uranium and plutonium type of sources, and 30% by thorium alone. Oh, great, guys. It means India is working a lot also for thorium, and this is the thorium vision of India. Okay, so as just I mentioned here, guys, I hope you people have not any doubt in the understanding of, in this whole of 25%, base 70% by uranium plutonium, and here in this 25%, 30% contribution by thorium alone. I want everyone answer, sir, clear. Clear. This thorium vision, I hope you people clear. I know, guys, mostly concept is required, but apart of it, some factual data even also support you to write your quality answers if you are writing in the mains paper and all. And at least you will have a broad perspective when you go into the interview, guys. You will have an understanding, oh, India is visionary for it. And last year in 2020, that question came about nuclear energy's growth and importance of India and its pros and cons. The pros is definitely, guys, massive level of power generation is possible. Renewable energy, a lot of input you are using, but accordingly lot of output not comes. But in the case of nuclear energy, a lot of input we are using, but outcome also a lot of here in this case. Those in the renewable energy not possible. Oh, great guys, great. So thorium vision of India, write one line. 30% of 2050 target. 30% of 2050 target. 30% of 2050 target. 30% of 2050 target will achieve by thorium alone. Will achieve by thorium alone. Will achieve by thorium alone. Okay, will achieve by thorium alone. Alone. So finally, nuclear energy, one portion over. Tomorrow we'll start from ITER reactor. Tomorrow I'll start nuclear fusion experiment. 3 questions UPSC also asked. Tell me guys, in this 3 hours of discussion, I hope you got it as benefit or not. Because I just want to ask you after every 3 hours of my entire discussions, that literally you feel something different, you enrich in your knowledge. And one more point that is very, very important for a teacher, that you got an interest in the subject or not. And another one, those myth about the subjects. Now I hope it is broken here. Okay. The reason is actually it was not possible to come at everywhere to take your classes because I'm only one person. And definitely not today, but maybe after tomorrow, after day after tomorrow, when you people clear this examination, people start to believe on it. Okay, this subject have also need a proper strategy. It's not only go and take it as a cup of tea like the current affairs. No, proper plan the subject as like to the humanity subjects. And I made this subject, guys, don't worry. I have written this book, this was a reason. And this book literally flourished so much fast. The reason is there was nothing in bit earlier. Okay, even in the environment book, I'm also telling you, trust that book also, guys. Because of lockdown, I could not reach to the many places, but trust on this book. Okay, I'm very honest man in this profession, especially. And literally guys, because of your selections, when you people openly start to say, no, science and technology still have a need of proper strategy, and through strategy, okay, if you will listen the Ravi sir classes and read the book, you can grasp questions, you can solve questions. Okay, so now you people all give me a very beautiful and cute smiley. Okay, with your confidence, that is very, very important. New generations are here. So in the new generation, I said that in the form of smiley, you represent your feeling. Yes, you people feel very comfortable. And literally, I made this subject easy to you. And now you people still understood this subject is also a subject. Okay, and here you people believe now because of me 10 plus answer question you can solve. Science and environment both if you will listen guys. So around 15 question also coming from the environment, 12 to 15. So 20 plus question you can easily solve. Yes, but with current updates also. Okay, so I want you all smiley guys because your satisfaction is my career. Your selection is my career. I believe on it. People are telling I'm a good teacher, best teacher. Again, I'm telling you it does not matter. After your selection, when you say, literally, I was a good teacher, then it will be proof. Neither every teachers in the professions believe that I'm the best teacher. As like every students are believe, now I'm a good aspirant. So everything will be proved through your selection. So that is the reason your selection is my career. And I know it very well. And I spoken you the same statement also earlier that your selection is my result. If I'm a good teacher, your selection will prove. Okay, neither if I'll have a 2 crore rupee, I can advertise the best teacher. So I will be popular. But no guys, in that way, I don't like to be popular. I like to be popular through your results. When any media in front of it, any newspaper in front of it, you mention the name of me, my books and my classes and about site where you got a platform to achieve it. So wonderful guys. So one more myth in the science and technology is most of the answer for the question in all of the above is it true? Pradeep is right. If 2 questions, but it is a last day when I tell you about the elimination process. If in some answer you are getting it like 2 of the answer is right and 1 of the answer you definitely blurred, you don't know. So my suggestion will be, and you know very well you are not getting select. So my suggestion will be you take 3rd will be also right. But as a teacher, I should not advise this type of things. It's a media. And you people are going to see every videos, those I'm telling you, it's a safe here. Even if I will be no more, still my videos will be available there. Maybe in 2121 when the people are listening my videos. Okay, and that time there's some scenarios and some pattern will change. The people said that I was fake 100 years later on 100 years. Okay, so that is the reason this type of statement is not right. But Pradeep, I cannot even say that you are wrong also. So very interesting lecture, Muskan, very beneficial. Thank you. So okay, fine, you are praising, it's good. But I want to praise you after your selections. Oh wow. Many of the smiley, I got it. Oh great. Oh, thank you. Oh, many of the smileys. Oh, great. So, okay, fine. Bye, guys. Have a good day. Oh, today nuclear energy concept clear. NSG and these all the topics. NSG, Shrikant, that discussion I will do tomorrow, I think. But tomorrow I would like to discuss about the scheme wala part. Some ocean energy, geothermal energy, some energy portion is still left, that wala part. Lithium-ion battery maybe I'll discuss in the miscellaneous topic. Solar pump, even I'll also discuss in the miscellaneous topic. Solar pump was a question in 2020 also. Okay, so Shrikant, I'll discuss your questions. Shivam, thank you so much for your nice comment. It was highly useful for me for being science student. Okay, thank you, Sunny. Being a non-science background, I can definitely say to you, made it easy. Thank you everyone. Math is broken, Mahesh. Yes, just. And I request that you just spread this message to everyone, guys. Thank you. No question. Shrikant, being a science student, there was a lot of things I do not. Okay. Muskan, very interesting. Thank you. Yes, Pradeep. Science at all of the above is to giving your answer. Muskan, okay. Pravakar, very informative classes. Thank you. Biofuel policy. Shortly I can discuss tomorrow. I can discuss, don't worry, biofuel policy. Okay, but biofuel policy is nothing. Even I also told you about earlier the biofuel policy that 20% of mixing under the biofuel policy will start by 2030 and with ethanol type of things, and biodiesel type of mixing will start to the diesel by around 5% by 2030. And but the today have some news, guys, like 2023 India wanted to use 20% mixing of ethanol in the petrol. So maybe possible those under biofuel policies mentioned by 20% India will do 2030. Maybe India can start by 2023 onwards. So before 7 years of the target of biofuel policy. And the purpose is that those imports of the petroleum products we are doing, 30% import we can reduce it. Around 30% of import we can reduce it. So ultimately the lot of losses, financial losses those India is bearing because to purchase of the petroleum products from the other country, the 30% reductions. So we can save our money in the forex reserve. Those can be utilized for many other purposes. Okay, guys. So this is something about the biofuel policy I discussed with you. Okay. So quantitative per qualitative span of the knowledge. Thank you, sir. Energetic. Thank you. Okay, guys. Have a good day. Bye-bye. My class is over.